We could do open discussion. Okay.
Yeah. So look, just on the point I just put forward, how would people feel about a discussion in that space? Because it seems to me that any kind of propulsion system has to interact in some way with the background field, right? It has to, right? So even in Newtonian systems, the background field is the air, right? So even with what Mark's doing, trying to change the weight of something, that's changing the weight, which is interacting with the background field. We call it gravitational acceleration. So it seems to me, the idea, it seems to me that relevant that if the history of that background field has changed, are there any clues in that history that might help with ideas, experiments, etc., etc.? That's the question, and I just want to get what people might think about that.
What do you mean by change?
Well, for example, would you agree that the universe is different today, assuming the Big Bang model is correct, right? Would you assume?
I wouldn't assume that.
Well,
it was invented by a Catholic priest. Why would you believe it?
In order to answer your question, in order to answer your opening question, right? What I'm saying is, make the assumption, because you said, is it different, right? Well, the assumption is, let's start with the Big Bang. The initial state was, let's say, some dot, which is the accepted theory in physics, standard model of cosmology. And now we don't have a dot. Now we've got a much bigger dot, right? So everything has changed, right? So what I'm suggesting is that if we understand more about that change, the question is, might that be advantageous to, physical experiments?
It wouldn't be advantageous. I think it would have the opposite effect. If you assume that it's constant, it's not changing, then that's a variable you don't have to worry about. If you have some change, unless you know the rate and you know all the properties of that change, you're just creating too many variables for you to solve it. Is the problem. If you assume it's constant.
See, I disagree with that respectfully, and I disagree with that because the rates of change and all that kind of stuff is actually knowable, and it is knowable. I've calculated it, and it agrees with experiment.
Say again, it's
so
knowable.
The information, yeah. So all that rates of change, that cosmological history that I'm talking about, is knowable, and I've mapped it, and it exactly matches physical observation. So I think the idea of a static universe just does not fit the data at all. And it goes against the standard model of cosmology, which the vast majority of physics agrees with.
Do you believe in offset spatial divergence? Do you know what I mean?
I have no idea what it is. No.
Okay, offset, that's like if you're on Earth and you travel at 10% the speed of light for a year, and then you turn around and you come back, then the people that you knew when you were alive, they're all dead and gone because your time, because of offset spatial divergence. So
how is that?
Depends on your frame of reference, whether you're moving or accelerating or not. Wouldn't you agree?
Well, yes, but isn't that just time dilation? So
time
dilation, isn't that just a classical?
And it can either dilate, it can go both ways. It depends. Depends on whether you're accelerating or you're not.
I agree with you, but I've never heard, I haven't heard it expressed with those words, offset time, what do you call it? Offset
spatial divergence.
Yeah.
To travel,
so
to simply put it, to travel in space is to travel in time.
I agree with you. What I'm communicating is that I've never heard it actually labeled as offset spatial divergence. I've not heard it called that. I agree with what you're saying, but
well, I appreciate it's a new concept. I appreciate it's It's hard to wrap your mind around it because you just assume everything is constant, even though, but when you're moving, it's not. Things are changed. You're relative. If you move in space, you move in time, and vice versa.
Yeah, so I don't understand what you're trying to communicate, because
Well,
what you
space-time
said.
depends on your frame of reference. So, like, for example, if you're on the sun or near the surface of the sun, your time goes a lot slower because of frame dragging, gravitational frame dragging. Kind of like
so
when
that's
your
just
cell phone, when you're using your GPS satellite, the GPS satellite's time is faster than our time here on Earth because we're in a gravitational well. So
yeah, and that's just standard. That's standard GR.
So, but then you take that and you do special relativity, which is what I was talking about, where if you accelerate towards the speed of light, it changes the properties of time.
Yes, again, to my knowledge, that's not new information. It's not discovering America.
But
What do you
don't
suggest?
need a big bang for that. That's my
No,
point.
but right, okay, all right. So what I'm saying is that if the space-time manifold has evolved over time, can we learn? And if we want to develop craft that can travel through space, and one concept is faster than light travel, right? So my question is, can we learn anything from looking at the history of the cosmos where faster than light speeds have occurred organically, naturally? And it has, right? And the simplest example of that in the standard model of cosmology is inflation, cosmological inflation, which occurred in the very first moments of the universe. And cosmological inflation was inserted into the Big Bang model to make it work, right? Now, if faster than light conditions, faster than light kinematics has occurred naturally in the history of our cosmos, if it's a natural occurrence, that means it can in fact be reproduced, right? So what I'm suggesting is, is there any advantage to understanding, to discuss the conditions that occurred naturally? Will that, observing nature, is that going to help us invent machines? That's what I'm suggesting.
Well, that's what we're doing when we're looking in a telescope, is we're looking into the past. Because light travels at a constant. So if we look at Alpha Centauri, which is what, 2.5 light years or something away, and then it took 2.5 years for that light to get to us. So we're looking at the past 2.5 years ago. And if we look at like light from a galaxy that's a million light years away, it's 1,000,000 years old.
Yeah. Anyway, look, I hear what you're saying. My point stands. Is there any advantage? That's the question I'm asking the community. Is there any advantage to discussing the changes of the past to help us build machines of today? That's the question.
Well, it'd be an interesting presentation.
Hey, Riccardo and Michael, if I could just interject real quick, there is one scientist from UC Berkeley, Medina, Raymond Chow, and he was showing that tunneling, which totally natural thing, electron tunneling occurs somewhere around 1.6 C.
Yeah, it's faster. Definitely, quantum tunneling is faster than the speed of light, but not by a lot.
But what I was going to say was the only way that you would ever be able to see this on the cosmological side of things would be with black holes. If somehow you managed to be able to measure, which I have no idea how we would because it's so small. But if you were to measure this tunneling from one side of a black hole to another, coming through it or whatever, I don't know how you'd be able to see it. that would be the only cosmological way that I could think that we'd be able to see it, because if the wavelength of the electron is stretched across the entire event horizon, right? You see it pop in one side, pop out the other side, and you know the width of that thing, it goes across it faster. But like I said, unless you have a stream of electrons, it's pretty darn big.
A good example of that is a coronal mass ejection. What happens in a coronal mass ejection is so like a solar flare that precedes the CME, it has it takes about 7 minutes to reach the Earth. And if we're like we're right in the eye of the X-ray blast, it wouldn't harm us because of the atmosphere. But now a coronal mass ejection, it takes 2 to 3 days to reach the Earth, because it's like a big wave of proton flux heading towards the Earth, because part of the corona is thrown into space. And then that takes 3 days. But they discovered that on the opposite side of the Earth from where the sun is, a day and a half before, the decay rate of certain radioactive isotopes changes a day and a half before the coronal mass ejection occurs. So essentially there was some kind of signal coming from the sun that was preceded by the actual event a day and a half before it actually occurred. So that's an example where you don't need a black hole. It's just a natural thing that happens.
All right, so anyway, back to what I was proposing. Would the audience, generally the discussion around the history of the cosmos and the potential for faster than light conditions be of interest to the collective? That's what I'm asking.
I believe that's what we're about, actually. So like I said, I think it would be great if you would do a presentation or something. I think we're always open to new info.
Well, if I could jump in really quick, I just want to let you guys know that Mark is still working on things. He said that his sample is still swinging.
Yeah, it's dancing around over here. If you guys look on the side, we're just going to wait for it to calm down a bit. The RF is ready, but we're just waiting for the sample to calm down. So you guys continue open discussion for the 5 minutes.
Okay.
And I just found, here's one example of it. Let me see. New system could predict solar flares, give advanced warning. I'm going to paste this into chat. Oh, and they're predicting that it may be neutrinos that do it. That's what the sum of the article. That's the.
Yeah. So the article says Fishbeck and Jared Jenkins, a nuclear engineer and director of radiation laboratory in the School of Nuclear Engineering, are leading a research study to the phenomenon and possibly develop a new warning system. Jenkins monitoring a detector in his lab in 2006 discovered that the decay rate of the radioactive samples changed slightly 39 hours before a large solar flare. Since then, researchers at Purdue have seen similar variations in decay rates before solar flares. The phenomenon represents a possible way to predict solar flares, allowing satellites and power grid operators to take steps to minimize impacts and astronauts to take cover from potentially lethal charged particles emitted during a solar storm. Large solar flares may produce a coronal mass ejection, of highly energetic particles which can interact with the Earth's magnetosphere, triggering geomagnetic storms that sometimes knock out power. Solar activity is expected to peak over the next year. And so as part of an 11-year cycle, that could bring strong solar storms. Let's see what the date is. That's 2012.
All right. I think John's got a question for someone.
John, go for it,
John,
sir. We're kind of an open discussion, so you don't need to raise your hand, but go for it.
Hey guys, on the topics at hand of observations of faster than light phenomena, I would throw in that there have been some successful experiments with what are called optical and sonic black holes. Now, they're not to the point of wormholing across it, I would say, but basically, loosely interpreted, these results show kind of a wormhole across horizons. The neat thing about these phenomena is they're not gravitational black holes. So you look into this, it's pretty far out there sounding, but if I remember, these guys pulled this off where they detected Hawking radiation from what they call optical and also audio or phonic. There's some word for it.
Acoustic.
Black holes of sound and light. Right? Have you
Yeah,
guys heard about?
Yeah, it's
I think it's acoustic black holes is the expression.
Acoustic black holes.
Yeah.
That's the sound version. Yeah, and
it's called acoustic levitation.
yeah.
That's what I showed earlier. That's what that little
Acoustic.
device was I had with the styrofoam. That's an acoustic levitator.
That might be a
It's a
little
combination of
different
both.
than I'm talking about Hawking radiation, basically from a bandstop filter. If you have a filter that's clean enough in the noise spectrum, you can detect the production of particles corresponding to Hawking radiation of that, that situation that you're creating by stopping the wave phenomenon. So it applies not just to light in the optical black hole situation, which is more familiar, more like what Hawking talked about in the chapter Black Holes Ain't So Black in A Brief History of Time and in the technical publications that led up to that. But it right with the wave particle duality, it turns out that they calculated this should work with sound as well. And I believe that was an Italian experimenter. But I don't know what we can do with it. It's like it's easier to tunnel across a barrier at this point than to build a tunnel through ordinary space. And of course, these are across microscopic degrees of freedom. There's really no hope of opening up these tunnels for a spacecraft or something, especially in the case of a man-made optical black hole. But
Unless we can shrink them.
Unless we can shrink them a whole lot. Well, that's what's interesting. I was hearing about NASA's plan of these solar sailed craft with the laser booster, basically, and the things about the size of the sail's huge, but the thing getting pulled by the sail is like the size of a microchip. And they're talking about 20% of light speed, and this is an official project they're trying to get funding for already.
Yeah, I
But
had heard something about that.
Yeah, just kind of establishment or mainstream approaches are getting into some pretty interesting results. As far as observing the basically cosmological constant at work and seeing the universe expand at faster than light speeds with reference to remote locations to that which is, traveling. I think this kind of paid off in the Alcubierre metric and its successors. I think there's a new version of the Alcubierre metric that does not require a negative energy condition.
Yeah,
Now,
correct. Yeah.
of course, these are still just monster energy fantasies where we're going to be able to basically detonate a whole star at one instant and travel apparently to reach the energy costs. But I have heard there are researchers trying to rein that stuff in too. But just a couple of thoughts on stuff that people are working on along the lines of what I'm hearing. But I think on one hand, in the 20th century, say in the bomb era, people thought the faster than light was going to take, maybe a couple thousand years to figure out. I think we could be on track to see it within a couple hundred or less. I don't know. So maybe somebody in here, like say the this like I don't know. I don't want to say the, what do we call it? Inertial drives. And some of these experiments, and there's not a great explanation for them, but we see maybe some weight reduction or something. Some of us might tend to be a little bit uncharitable in our assessment, but I was looking into kind of related phenomena in the mainstream, let's say, and in general relativity, there's this notion of swimming. This was big. They even got an article in Science Journal, right? The biggest overarching journal in the, all the big wig academics. And there's this notion of swimming. And if you kind of move something around in a sophisticated way, in the presence of a strong gravitational field with gradients far steeper than the Earth's, it's thought now to be possible to kind of move strategically, to move the mass within, say, a vehicle strategically to greatly ease travel, even through a strong gravitational field. You guys might be interested if you haven't heard about that. I know we were talking about gravitomagnetism earlier, and kind of we lump in there, I think a lot of us lump in there kind of E&M versus gravity as well. And there's actually some good stuff on this. This physics professor, I guess his name is like Jim Ranchler or something like that. I think he's at a university somewhere in the US. He's got this podcast, Physics Frontiers, and then there they got a great, in their episode on electromagnetic propulsion and gravitomagnetism, they've got a wealth of resources of references, on the subject. And this goes back to some of the earliest pioneers in applied relativity. And apparently they calculated there's a power law relationship between regular electromagnetism and gravity that can be exploited at short distances. It's just that no one has a physical material that can actually have the density of the magnetic flux required to see a huge kind of amount of power come out of it. But it turns out that plasmas can be magnetized. And this is what I would recommend people to look at, because it turns out that quite a strong density can be held in a plasma. It's kind of the inverse of the thinking of the tokamak reactor.
Just on a sort of taking a different direction for a moment, I'm just wondering what you guys or what the community might think about, do they know of any Chinese efforts in this space of electromagnetic propulsion and stuff like that? Because I noticed on the page on ResearchGate, I noticed the link to my work regarding Bob Lazar. It's called Analysis for Claims Regarding EM Propulsion Systems. I noticed that there's been a big jump in a Chinese audience accessing that information. So I was just wondering whether you guys have heard of how seriously the Chinese Communist Party is taking this kind of thing. Anybody know?
I don't think it's a communist party per se. I think there's Chinese scientists that are working on it. I have some friends that are, this device I got is from China. They have their own, they're working on it, is the short answer.
Yeah.
But is it a government funded program? I suspect it's like our government's funding. We're here, we're doing it. I don't, I mean, there's been a lot of, there's like the Pius, Salvador Pius patents and stuff like that. The government definitely has funded certain individuals that they have some level of confidence in doing the research, but there hasn't been any like Manhattan Project type budget behind any of it. It's all small scale stuff as far as I can tell. So
I was just wondering, I was just trying to relate it to, you know, you would have heard claims by various presidents in the past of stealing intellectual property and stuff like that on a large scale by the Chinese Communist Party across whole different areas. I was just wondering whether this.
Can I throw in on the China connection, Ricardo? The Chinese government invested in a paramagnetism based, what they're calling an anti-gravity chamber. It is, if I remember, it's too small for a human to get into, but it's much larger than the floating frog experiment with paramagnetism. And they claim this gives them a tunable gravity environment where they can simulate partial Earth gravity, like they can actually tune the paramagnetism, they claim, which if you think about that, it seems like a bigger claim than just canceling the Earth's gravity with paramagnetism. But
just want to give you guys an update. The sample is still shaking, as you can see in the video. I have a call at 7:45 until 8 o'clock, so I think we'll just hold off on this, let it settle down until 8, and hopefully it'll be calm enough by then, so we'll be able to get some accurate readings. So just keep the open discussion going.
Okay.
I saw Bernie has his hand up. Bernie, are you there? All I see is the top of your head.
Hello. Sorry about that. Trying to find some YouTube links to my buddy at Faraday Research's latest videos in the meantime until he joins in. But he's got some interesting stuff.
Faraday Research is here, and that's Alex Frolov, right?
No, Mike from Faraday Research. He's from Toronto.
Ah.
Oh, there he is. There's Mike. Mike, you can unmute yourself and give a better description of who you are.
Yeah, I kind of feel out of my comfort zone here. Everybody's talking about anti-gravity. I'm more into the energy stuff. But I do think the energy and the gravity have a very important correlation with each other. I have some theories on anti-gravity. And I was listening to a lecture by Eric Dollard. I don't know if you guys know who he is. He's been pretty much studying electricity his entire life, worked for RCA, worked in Bolinas. He's got a very huge background in electrical engineering. And he had this theory that kind of goes back to Tesla, what he was talking about. If you're able to find the universal grounding point of the universe, everything like inertia, all that kind of stuff would basically go to zero. So, you know, you could stop on a dime basically, and how can I put it in proper sense? It cancels everything out. If you're able to ground yourself to the universal grounding point, because us, like, we're on Earth right now, we're traveling through space at a huge rate of speed, and we're also in a spinning motion. So if you're able to find the universal grounding point of space-time and stop yourself in that universal space-time to zero, everything else out, all the forces of gravity, inertia, all that kind of stuff basically stops, because you are in the universal grounding point. I don't know if that resonates with anybody. I'm more of the energy field, so
Would you know if the grounding point is actually a point or is it a state?
I think it's the state.
Yeah, like an
That's-
inertial
Yeah, right,
state
yeah.
almost, hey,
Right.
Mike?
Okay.
Yeah, it's a
Relative-
cancellation.
Spinning.
Yeah, because the Earth, everybody in it, we're going through space at a huge rate of speed. All
And then
right.
we've gone around
So-
the sun, and the sun's going around the Milky Way.
That's
and
right.
the Milky Way's going in the universe, and so it's like everything's in constant motion.
That's right.
And so what
That's
you're
right.
suggesting is if we could find the quote ground state of the spin of the universe
the
of
zero
Right.
point of it, which would essentially be also your singularity to start from a neutral in a wormhole or portal, I guess, is also what Mike is essentially describing.
well, it's kind of like it's a type of fractal. It's
Mhm.
kind of like you think about the atom, and you look at it, and it looks just like a galaxy. Okay,
Mhm.
so it's like real tiny, and then something the same thing repeats over and over again.
Right.
So it's a
And- Yeah, as far as I
multiverse.
know, there was some
Multiverse.
writings that Tesla was doing, talking about this universal grounding point, because all the electrons, say you're traveling through space, any matter that is in space, like the ether, it's rubbing off you. It's like you driving in the car and you slam on the brakes and you got that screeching noise of your brakes. That's the electrons in any matter that's in ether affecting your body, but also leaving your body behind, leaving a trail. So Tesla was talking about if you can find this universal grounding point, it cancels everything out. Gravity, inertia.
Yeah, and then you could teleport to wherever you want to go.
Yeah,
And then
so
time
now,
travel would be possible too, because it's all part of that.
yeah, it's all related. I think, we're getting into the quantum part. It's not
Yeah,
just
exactly.
gravity.
Something real tiny. It's not
Yep.
something real big.
Yeah.
It sounds to
Can I-
me like that.
Go ahead, hop in.
We're going.
Can I suggest that this point, probably the closest in our solar system that we can find to this will be your stable Lagrange points. I can talk about the difference between the unstable ones also being attractors in a local gravitational field, but they're a repelling type attractor, and they don't have this property in the exact same way. In some ways, it's probably heightened as far as their attempt to show quantum gravitational effects. Now, I can't promise teleportation or something. I would suspect those type of experiments would be easier to be more successful with less gravitational input in the local field. But my thinking is the only thing I've predicted so far about Lagrange points, I think that in a quantum field, a quantum theory of gravity, Lagrange points should have their own Lagrange points. So if you look at the equation for finding Lagrange points, you have this like radical in the denominator, you have this absolute value in the numerator. And this is like kind of a nested radical kind of system. If you iterate that again, you get another whole set of solutions of, I guess it goes like cubics, and then there's like 25th order or 10th order. I haven't looked at it in detail. I'm still trying to hash this out. But
So gravity is a parabolic force. So that means that if you factor it, it has two real factors, right? Anti-gravity, on the other hand, is a hyperbolic force. So that means it's distance cubed over time cubed dependent. So it has three factors, one real and two imaginary. But we know it's real.
Mhm.
We know both of them are real effects. So there's part of the universe of space-time is in an imaginary realm, and part of it's in a real realm. Just
I'm
based
glad
on-
you mentioned basically, right, the complex plane. So we're
Also,
looking
that
for solutions
other term for like the multiverse, but also quantum realm. Is that correct, Boyd?
Yep. So there's a multiverse of different, it's like there's a little tiny universe and then there's a bigger universe and so on and so on. It's like a fractal. Starts out
Yeah,
with something
fractal,
and it
yeah.
repeats over and over again. And that's what we call expansion.
If we look at the Lagrange system as a template for this fractal and its branching, it has what's called a forbidden symmetry. For organized matter, you're allowed kind of crystalline symmetries, which have 4-fold, 6-fold, certain even-fold symmetries are allowed, not the 5-fold that you get with the 5 Lagrange points. This suggests that in a proper coordinate frame, that the universe could be shown to have a quasi-crystal structure, kind of a like a fractal state of matter, where that state of matter is inherent at a transition point.
Yeah, so John, kind of what I'm getting you picking up on is that there's multiple states of dimensional matter, like both higher and lower. Essentially, like crystals could maybe even be like a 6-dimensional state of solid matter, where plasma is our 4th state of matter, solid being the 3rd, and there might be an etherical that is the 5th that folds back into itself between the plasma and the crystalline or the higher dimensionals within this matrix.
So this is what makes life possible. How can you continue to have something continue to exist unless it's it's got to be better than unity to be able to grow, doesn't it?
Michael, that's a really great insight, and I'll say even further, the definition, going to the definition of life. I got the honor of teaching life science this time around. I said, wait, I'm a mathematician, maybe a mathematical physicist. My principal's like, you're gonna teach life science. I go, awesome, okay. So I'm studying the basics. What the hell is life? And stripping aside all the stuff we all know, that they reproduce, they eat, this stuff, you get to 2 main properties, and it's really interesting what they are. The first one is that it exhibits some kind of local order. The second one is that it exhibits a sensitivity to initial and boundary conditions. And you go, wait a minute, that second one, has no one noticed this? Excuse my French, that is the definition of mathematical chaos. So on one hand, you have order, and on the other hand, you have chaos. And the marriage of those two are to me, the 2 salient defining characteristics of life. But guess what? Those are the defining characteristics of the whole universe itself. So some of us might not have that kind of animist philosophy of the universe, and it's great if this doesn't resonate with you and you can't use it. But for me, this suggests that observership, while it looks like it was written out of the quantum axioms, watch out, maybe it'll make a return, and we do need mind to suffuse the universe for it all to work. This seems to be in line with.
Wouldn't that suggest that we're all the same life?
That's right. That's what that would suggest, right?
Me, Tim, Riccardo, we're all the same life, and we're looking at ourselves subjectively when we're awake.
We are individual fractals of a higher fractal dimensional consciousness.
I like your idea, Mike. So who can I send my bills to?
Who do you send your bill to?
That's right. Yeah.
Prime Minister
So you can pay
Justin
my bills.
Trudeau, I do believe.
The Grand Poobah.
Vladimir Putin.
You could say that the fractal circles are just nested vortices of time, spatial dimensions of different realities that branch off into different possibilities. Well,
vortices are a type of fractal. So
yeah. There is a guy named Anirban, I can't remember his last name, but he had made something on the nano brain he's currently working on like, you've heard of the time crystals that they supposedly had came out since, I think it was Google or whoever, was working on these crystals that, had different effects at past the virtual photon level or something where, they're supposed to go inverse time. But, in the like little space, you have your two barriers, and then in that space distinct properties act differently. So, but this guy has made this weird organoid type of, it's not even silicon he's using, I can't remember, but he made some type of organoid type of jelly, like little brain.
Organoid. Or
Yeah.
That's like that's the metal embedded in some kind of what is it, polycarbonate or something like that.
Yeah, some type of construction, like it's biomechanical, or it's really bio, but it's like not got any synthetic parts as far as like circuit boards or silicon or carbon. It's like what kind of like what we're made out of, stuff.
Kind of a filter, isn't it?
Yeah. He made
to clean your. It's like for EMF control or something like that, isn't it?
Well, it's made of like what DNA is kind of made out of, but he made this like little, like he programmed the biomatter. My mind is like can't remember. Brain farts. Like programmable, biomatter. Like they say our DNA carries information that can be reprogrammed. So it's basically he's using that concept, and he actually made this genetic nanocomputer basically, and it can calculate differently like DNA could, with information. And I have his whole book, tells you how to construct the thing and everything. Wasn't cheap, it was like $200, but he tells you how you can make it and what
do you have a link to it that you could put on the chat?
Yeah.
Well, when we're off.
Oh yeah,
Please,
definitely.
would you please post it on the chat so that we can all look at it?
Yeah. But you would have to.
Thank you.
Yeah, definitely. But his fun thing was, it's like he decided to, like, if a Fourier analysis could not measure, all the signal vibration, fluctuations exactly. So he proposed using fractal math to measure the fluctuations instead, and using prime numbers as the basis for it. So to let the prime numbers map out all the fluctuations. I don't know how that works, but he called it phase prime metrics. And then something about, he said that there are no parameters.
Yeah.
But anyways.
Ciao, guys. Sorry, I've got to get going. It's been really great listening to everybody. Really appreciate. Got some great ideas here. Anyway, just wanted to say that. Sorry to cut you off. I didn't mean to. So yeah, see you guys soon, I'm sure. Cheers.
Thanks.
Thanks again. Have a great, and Riccardo, thank you again. I would love to have you present again for us, sir, in the future.
Yeah, sure. No worries. All right. Thanks a lot,
Thank you
guys.
again.
Ciao.
What do you got there, Bernie?
So this is some monoatomic, and can you see that there's a little bit of video wave interference coming up on my camera around this?
Oh yeah, a little bit.
Yeah, I've recorded this on all of these plasmoid monoatomic structured elements.
So it's oscillating.
It will have that. Yes, exactly. Depending on the light that you have around it and the video equipment, it will range in wave or strength of interference. But this is a combination of monoatomic zinc, silver, and copper. I've made together there. It's the pure white fluffy stuff. I've been talking with Jeremiah as well as Esoteric Gold here in the past couple of days in regards to how they've made their monoatomic metals through the chemical treatment way of it. And then mine is completely different, where I'm only using a small voltage of electricity in salt water, and then the pure elements themselves as cathodes and anodes to then make and turn into this pure white single atom plasma state. And I essentially predict that it's the quantum matter, because it is this single atom plasma state matter that we are making. And it's that I learned from Isaac Newton's alchemy writings that he states that all elements can be broken down into this single white fluffy monoatomic, what he calls mercurial white state of metals. And I've turned,
So when you say mercurial, it's liquid?
he says mercurial. I believe it's molecular. It's just old English, like language differential.
Mercurial.
Yeah,
Mercurial. That means metal that's liquid. It's a liquid metal. That's what he's talking about.
yeah, but he's saying it's in this single white state that they come down to.
Yeah, it's white because, you know, it's
This single atom, right? Stuff.
Metals are shiny because they have free electrons. That's what makes them shine.
So
Free
the thing that
electrons.
makes
If
this
it's
stuff so
white,
special.
it's
My-
not free. It's in a plasma. Right?
So this stuff, I've been able to turn copper, aluminum, iron, nickel, gold, silver, bismuth, and I believe a couple more, all into this single white particle stuff through the electrolysis process. And that as soon as they turn blue or green, that's when it's oxidizing and it's particulating and it's forming that bond with another atom, thus no longer that single monoatomic plasma state. And it's that
Cool.
this ionized gas, right? Your noble gases in their plasma state, it's a single atom, but it's super charged, right? It's ionized. So that's what essentially these monoatomics are, is it's the noble metal elements in their single plasma atom state. And with Keshe's research, when they rotate these metals at 4,000 or higher RPM, it starts emitting measurable and usable plasma fields that you can read and register throughout the air with the electromagnetic fields they create.
Yeah, it'd be cool to X-ray that, see what the atomic structure looks like.
Yeah, so I have lots of these different samples and I can make them out of specific metals where I'm using 24 karat gold, both anode, cathode, same like 99.9 silver when making them, so that I would love to produce controlled specimens to send to the proper lab. Does Mark, do you have the equipment there to test it? Or what would I be using? Because it is this monoatomic state the David Hudson stuff talks about essentially too.
We do not have a mass spectrometer, and that's the equipment I would suggest using.
I was talking to John Hutchinson about it last night, and he was saying it was some sort of microscope something.
I can help you out with that, Bernard. You can use your cell phone as a mass spectrometer if you do right like adjustments to like let's see, dang it, the accelerometer or accelerometer. I can't remember the name of it, but
Accelerometer, that's
Thank
like
you.
measures motion.
Yeah. Like if you can train that to detect the motion within the air as the vibration, pressure mediations, and I guess hold the phone close to the monoatomics, whatever, you can detect the different rate changes and all that. Maybe just going off by that, you can see if the, anything has been, detected and all that. So like you would have to cross, reference things of how mass spectrometry is, measure stuff with, the accelerometer, rate changes and how that correlates. But I'm just throwing that out there. That's what I've been experimenting with right now and reading. So how to use, novel devices and not needing, better methods for bigger equipment. Sorry, just want to throw that out there.
I'm just pinging Mark in the other line here. I want to see if Mark is almost ready for his experiment. Looks like his thing has quit swinging.
Sorry, I was muted there. But what I'm showing is the pure gold layer, and it's a crystallized, I believe, single atom, but nano layer of crystal gold that forms in part of this electrolysis process. And it falls off as straight sheets of this single layered gold flake. And that this would be the sort of things that you'd want to layer your whatever Charlie is working on, and that was just talked about, presented on the spinning discs there, is that you'd be wanting to put these nano layers covering of the different discs, and then some of these monoatomic metals either layering them or in the center of them rotating.
So I found a lab that could do that, what you're looking for, Bertie.
Awesome. If you post the link in the chat, I will copy.
Yeah,
and
it's the National Institute of Standards and Technologies. That's where you send your samples to get them. If you're gonna, like, they'll sell you standards for like your atomic force microscope or your electron microscope. You know what I mean? By a standard.
Gotcha. And is that applicable for me in Canada, or is that just an American thing?
It's it depends on what kind of money you have. I think you need US dollars for this.
All righty. So
the government respects money.
I'd probably go back to my local university first and approach them and see if I could use their equipment, I'm guessing then.
Well, no, what you do is you find out what their equipment is from NIST, and then you find someone in Canada that can do it for less. So I posted the link here in the chat.
There's Mark. Mark.
Yeah.
There he is.
Sorry, Mike, do you want to go into more if it's still open discussion, like talking
Okay.
about how you've done your M machine build, your Don Smith spark gap generators, your pulse mode?
Bernie, we have like
Mark.
two or 3 minutes until it warms up. So go ahead.
Okay. So Mark, when you take over to your presentation, can I make you the host for open discussion after that? Okay.
Yeah, sure.
Oh, shit.
Okay.
I put it, I didn't put it to everyone, the link. Sorry, Bertie.
No worries. And Mike,
Okay,
do you
there it
want
is.
to
Now it's there.
What was that, Bernie?
Oh, I was sharing a link. He was looking for
I'm
a
forgetting the metals test, but Mike, if you want to talk a bit about how you're connecting your Don Smith generator into the different transistors and then into the pulse motor, and then you're making a flywheel build as well into it.
I don't know. I'm confused. That's not my project that I'm aware
No,
of.
that's Faraday.
Well,
I think he's muted.
Yeah, no, I'm here. Yeah, I did an interesting experiment about a year ago. I made a miniature version of the end machine. And, if anybody knows how it works, I took two, those fishing magnets, really powerful N52 magnets, 3-inch diameter, and I spun them at about 4,000 RPM. And I noticed an interesting anomaly. When I hit the shaft of the end machine with high voltage, the machine started to trail across the table. And I thought at first it was the vibration from the end machine itself. you know, because of, you know, it's not properly balanced. But it didn't do that as soon as I shut it off. The second I hit it with the high voltage, I was hitting it with about 6 kVA at about 42 kilohertz. It started to trail across the table. It started to vibrate, and then it started to trail across the table.
Is it jumping?
That's what I thought at first, but the second I stopped putting the voltage on it, it stopped. It just basically sat there and spun. So the second I put the high voltage to it, it started to trail across the table. I actually had to hold it back.
So if you
So-
kept it at a high voltage and you adjusted the frequency, did that change anything?
Well, I didn't actually have a frequency control with the high voltage modulator that I had. So that would be an interesting experiment to actually, if I was able to actually
You could
the
tune it
frequency.
in and then it goes flying across the table.
Well, I literally had to hold it. It was trailing across the table. I had to hold it. And the second I shut the power off on it, it settled down and it rested firmly on the table. Now this apparatus weighed about 20 pounds.
Was the whole apparatus vibrating?
I had everything. I had the power unit. I had everything on basically not a masonite board, MDF fiber board, and I had the whole apparatus fixed to that apparatus, to the board. And then as soon as I flipped the high voltage on, the whole thing just started
The
trailing across
board
the table.
that it was sitting on moved too?
Yes,
So the whole thing, the whole assembly was vibrating at the same frequency, correct?
yeah, yes.
And so was it, and you couldn't adjust that vibrational frequency?
No, because that high voltage generator I had was a fixed frequency. I wasn't able to vary. The only way I could vary the frequency is if I start playing with the voltage input and output. That was the only way I could maybe alterate it. But the higher the voltage went, the faster it wanted to push across the table.
Huh.
Now, originally I thought it was vibration.
5 kV, you say?
6 kVA.
Because if you had a bipolar amplifier, you could do it.
Yeah, if I could.
You know what I mean? You
modulate
could
that
pulse it.
frequency.
You could pulse it and then create a on-off state at a fixed frequency.
Yeah, I just never really pursued it because I was more into the energy stuff. But
Yeah, but you
know,
said it
was,
stopped when you turned the power off, right?
That's right. Yeah.
So what I'm saying is you turn it on and then you turn it off, and you have a duty cycle essentially. Create a duty cycle on off,
Right.
and then you increase the duty cycle until you get a 50% duty cycle. Then it's a perfect square wave, right?
Right.
And then you can basically you can adjust the frequency.
Right. See, originally this is not what I was looking for. This was just an anomaly that popped up that I found kind of weird. Because, you know, like I said,
Well, don't stick on DC. AC is where your money is. Look at that's what Tesla did.
Right. Well, exactly. You know, it's pulsating at 43 kilohertz, so it is technically like a pulse DC, right? So, I can't explain it. It was very strange. I wasn't originally looking for that anomaly, but it just happened, you know, basically by accident. So,
Serendipity. I think
But
we're
I've
all
had-
familiar with that person. Serendipity.
but see, it kind of it was
Guys,
weird.
we're just about ready here.
I'll just
Okay,
mute myself.
we're just gonna start by turning on the magnetic field.
Do we got Mark getting ready to fire this puppy up?
Yep, it looks like he is just about there.
Oh, I got a quick question that you guys brought up. What do you guys know about plasma rectifiers from old world, like 1900 technology that they used for switching DC to AC or AC to DC in the old system?
Are you talking like tubes?
Yeah, it was
That's
plasma.
that's thermionic emission. Yeah.
Yeah, but it was just, they were everywhere. You can look at these old pictures of the electric cars from 100 years ago, and there's these giant glass tubes with these plasma mercury at the bottom, and they're called mercury rectifiers, and they state that it was used for transferring DC to AC.
probably
Yeah,
just
they-
outmoded by.
They used them in
But they would
old,
never burn out.
old black and
because it would
white
replenish
TVs.
itself as the mercury was in it, creating.
Old black and white TVs. That's where they use that kind of stuff. The old black and white TVs had that kind of flyback.
Okay, guys, we're rock solid with the measurement here at 32.0231 grams. So the magnetic field is turned on. Haven't seen any change in weight. We're going to turn the RF on. 3, 2, 1. RF is on. Change the frequency a little bit so I get less reflected power. Checking it over to pulse. Not seeing any change in weight there, which is slowly shift through the magnetic field, raise the power a little bit.
You're getting change there. Increase, increase. Oh, big, it just jumped.
Oh, there was a bit of a decrease. Oh, look at that.
Yeah, you just lost like 8 microgram, 80.
Oh, no, it's dropping. It's dropping more.
Yeah.
Oh, now it's coming back. Maybe a truck drove by. No, I don't think a truck drove by.
I can see it moving a little bit.
Okay, we're at 9.2326 gigahertz right now. That would be a one more frequency. Pull up the calculator real fast. That's 9.2326 divided by 28.025. So the one more frequency for that would be 3294.4 Gauss. So we're a little bit too strong on the Gauss right now. Magnetic field is too strong for this. I have to drop it. Somewhere around here it should happen. Sometimes these experiments can be as exciting as watching grass grow. Fully going through the range of frequent of magnetic field strengths. Just call out when there's a big change. Yeah. Nothing significant yet. Definitely reduce the noise by waiting that half hour. I'm slowly shifting the strength of the magnetic field 0.1 Gauss at a time.
Okay. How are you doing, Mark? It looks like it's still decreasing.
Oh, there was a big drop there. Oh my God, yeah, it's dropping now. Go back up a bit. Yeah.
So, and you've explained in detail what you're doing, right?
I have. I mean, I explained it quite a few times on the conference.
I was going to say, well, now that you have the results running, I mean, it's probably worth running through it again, you know, because it looks like you're having some kind of a breakthrough here, man.
I don't know. These are numbers in grams, so you're looking at 4 points past the decimal point on a gram. That's a 10,000th of a gram.
Yeah, but it's still a positive result. I mean,
Yeah, it's definitely moving. Yep. We had it rock solid before. We waited half an hour. It was rock solid when it started. I want to find that sweet spot where we'll lose a full gram. Then we'll get excited. Can you call out the negative, positive? It's just slowly going
okay.
down.
Well, Mark, I'd like to make you the host of the conference if you're open to it, or do you want me to wait for a couple of minutes?
Why don't you wait for a couple of minutes because I'm not next to the computer.
Okay, yeah, that's what I was waiting for.
Slowly going down. Oh no, that was significant. 84 to 77. Or more significant.
I'm not really hearing any audio, Mark. Oh, okay. You're just being quiet, that's all.
Yeah, being quiet and the hum of the equipment is probably drowned out or cut off by the Zoom. Just turn off the magnetic field altogether. If that does anything. Magnetic field is pretty much gone right now. RF off. RF field is off. I don't think we're seeing much this time around. We got the RF off right now. Magnetic field off. We have to pump up the power a little bit. Try a little higher power level.
This is much better than grass growing. This is rivals up there on the level of like watching paint dry.
Yeah, pretty much what it is. Much easier to watch it when it's in fast forward.
Oh, absolutely. So yeah.
Sometimes you see stuff that you don't see in the live stream when you're doing it in fast forward too. Sometimes
That's true. Yeah.
I'm going to spotlight Mark because that way you guys can talk and it won't disappear.
Oh yeah, I actually have two windows open right now, one on each screen. I just put everybody in the gallery on one window and then have him focused on the other one so I can really zoom in and see what's going on. It's too bad he doesn't have more gauging that he could basically throw up on the screen too, so you can see what else is changing while these slight fluctuations in the gram rate weighting is changing. Like any frequency changes, any, you know, fluctuations in like the amount of power going in and whatnot.
Change the pulse frequency. So we have several things going on here. We have the RF, which is the pulse. The signal generator here for the pulses is on a sweep mode between 80 and 160 hertz. Actually, between 60 and 160 hertz. It's sweeping every 2 minutes. We're right about where more per session should be happening. I notice that when I'm off the frequency band, the weight is pretty steady. When you start getting close to that or more per session, that's when the weight, we're seeing the larger fluctuations in weight. But these are 10,000ths of a gram. They're not major.
See if I can pull this, give you guys a better view of what's going on here.
It looks like you're graduated all the way down to 10,000ths of a gram. So 2-digit movements is 1,000th of a gram.
Yeah, so this is that's a signal spectrum analyzer over there showing us the pulsing RF frequency. Those blue lights over there, that's the forward and reverse power. So we basically our SWR meter. Tells us how much reflected energy we have coming in. Radiation detector, RF spectrum strength detector. This is a signal generator, RF amplifier, and this is a signal generator that is low frequency that's controlling the pulses of this signal generator, which is at 9.24 gigahertz. Down there is the magnetic, the electromagnet's power supply. We hooked up 3 extra pots. I think they're 10-turn pots to control the current. And on the wall in the back over there is a Gauss meter connected directly to the electromagnet. Right now it's at 3271.3 Gauss. So it should be right around the magnetic field strength necessary for a little more precision.
So I think I recognize that signal generator. Pretty sure I got one on my shelf in the back there.
Have the same model?
Oh, let me look and see, man. Yeah, looks like it's probably on the back side of it. Got it buried underneath 2 oscilloscopes, so. I guess I don't have a model number on this thing anywhere. It just says 200 ms a dash or // 12 bit. There was the one I've got is something cheap, marked as a K-Moon brand. I tested it on the good oscilloscope though, and it's pretty accurate on its frequency output whenever you adjust it. So.
What was that for? 0.014. Oh, okay. Well, we shut everything down pretty much. You guys got a little view of what it's like to run these experiments. We normally run them for about an hour, shifting all of the parameters and all different variations. It's about as exciting as watching grass grow.
Do you have an XRF there?
That's Expand RF, yeah.
No, I mean, do you have an XRF like spectrometer for, poking at things to see, it basically gives you readouts of what material you've got. So if you have a table, you're not sure what all might be laying on it, you hit it with that and it would be able to tell you what, not only what's on there, but what percentages of it, like uranium and gold and all kinds of stuff like that. And if you're working with the material, you know what it is and be able to poke at it while you're basically attacking it. You may see some potentials for using for transmutation for materials that we do need, that this would maybe open a window to. I know they're expensive. That's why I was thinking we need to see if we can't get you guys one,
That would be a great piece of equipment to have, because we need to look at this from a lot of perspectives. I also want to get some maybe slightly radioactive materials, see if we can use this technology to lower radiation levels.
It'd be pretty ridiculous if you were doing something trying to develop anti-gravity and stumbled upon the secret to really making cold fusion work.
Well,
I heard
so Mark, I want to make you the host now, if you're okay with that.
Go for it.
Okay, good
You
deal.
can't wait to bounce, huh?
No, I gotta make dinner for the gang. So.
Uh-oh.
Yeah. Okay. So let me find. Yeah, I will be back probably about an hour or so.
Yeah, don't
Okay.
want next time we see you see chunks missing from you because the zombie horde attacked you instead of the food you made.
Okay.
Heard, Mark, I heard Shugnite, I think the mineral, SHUGNITE. Like
Jeremy, can you turn on your camera? I'm just asking everyone who speaks to turn on the camera.
Oh, okay. Well, no one mentioned anything, so you.
Yeah, we can see your hand.
Okay. Yeah, but I heard Shugnite mineral supposedly like reduces like excess radiation.
I think he can turn off his camera.
Well, I mean, right now I'm in a dark room because like it's easier on my eyes. So, you know.
No, I can't.
No, we can't see you either way, but
That's cool.
Shugnite, not familiar with that material.
Better to just give us a proton count on whatever it is this element is the elements it's supposed to be composed of.
So we got over here, this was based off of Aidan Schaefer's recommendation. He said I should get some magnesium orthosilicate, which is otherwise known as ferresterite, powdered. So I got some of these magnesium orthosilicate samples. They came from Afghanistan or Pakistan, whatever. And I took one, we crushed it up, ran it through the mill, and we ended up with this powder over here, magnesium orthosilicate. Of course, this is like this is a compound similar to ruby that's made out of aluminum. This is made out of magnesium, which is also a good retainer of dynamic nuclear orientation. So we were going to try some experiments using the magnesium orthosilicate powder as well. And this is also used in cosmetics. Me and Tom got some really nasty headaches when we were making it. So I don't know if it was from the powder or from something else.
I got a question for you.
Yeah.
Going back to something you were talking about earlier. You said you were seeing a diamagnetic response from that aluminum, but you quoted it as being the property of aluminum. Are you saying that it changed this property? Because aluminum is marked as being paramagnetic at room temperature under normal circumstances.
I may have misspoke. What I was referring to is the aluminum.
It's a monoatomic aluminum.
Aluminum's capacity to retain dynamic nuclear orientation for an extended period of time. And by extended period of time, we're talking milliseconds at room temperature.
Right. Yeah. On that scale, that would be basically a pretty decent amount of time compared to what
So
we
like
think of whenever humans.
Aluminum and magnesium are supposedly from the best materials for retaining dynamic nuclear orientation at room temperature.
And we
as they got colder, they work better.
Right? Sorry, I just had to ask. Shugnite, not Death Row Records.
Well, I say you were using something that was within a magnetic field, so diamagnetic and paramagnetic would matter, since diamagnetic is a reflexive or a mirror-like effect of a magnetic field, whereas paramagnetic is more like a lens, a focusing agent. Doesn't create any of its own magnetic field, but it can focus one being affected onto it, unlike ferromagnetic material that can be oriented to generate its own magnetic field. So
basically trapping the waves so that there's no loss in signal gain, right? So you using different crap like
Thomas Anderson, I may say I believe aluminum is both diamagnetic and paramagnetic, although the paramagnetism is much more powerful than the diamagnetism in it.
Well, it seems like almost all materials can exhibit any magnetic property. It's dependent on different functions like temperature range. If you raise the temperature of a neodymium magnet, it'll exhibit like a loss of its ferromagnetic properties. Then you end up losing it. So yeah,
that's called the Curie.
And that's right. And that's just one property to change. I mean, if you're changing properties using microwaves and whatnot, you may see something change from paramagnetic to diamagnetic that normally requires negative sub 100 degrees below zero temperatures happening in room temperature. So
also if you make materials bring them up to a high enough positive charge where you strip their electrons from them, you can have copper that is as resistant as Niconol wire, where it just becomes your resistor because it's got no electrons left.
Wow.
So positively charged. It's possible.
So basically turning copper into plasma.
Well, plasma is actually very conductive, but you're
right. And plasma though is when you've separated all the electrons away and pushed them to a different region, so you have a bunch of cores.
Well, in plasma, the electrons aren't necessarily gone, but they're not bound to any one atom. So,
right. Well, that's what I'm saying. Yeah, you push them further away from the core than would normally be able to maintain
Right.
an
So
orbital
many
momentum.
plasmas actually are very near superconducting.
Right. That's why I was thinking that you can get like hundreds of thousands of watts worth of power through a tiny thin little wire by simply running it through it, like say 40,000 volts, because you're running next to no amperage, but you're still transmitting the work potential from one end to the other. Whereas you lose all that energy if you run at a much lower voltage, trying to jam all those amps through. I'm wondering if that isn't because the higher voltage is causing an orientation where all the atoms are lining up. So therefore, when you jam electricity in on one end, it's popping out the other end instantly instead of some of the energy being lost to, disoriented atoms, the electron fields on the atoms. So
I always thought the amperage was the resistance. Is that correct? I'm kind of a
no, the
novice
amperage
here.
is the quantity of electrons being jammed through, and the voltage, from what I understand, is the speed and pressure at which you're jamming those electrons through.
Okay,
So-
okay. The voltage is the signal gain, right? Like that's the safe part you can touch, kind of like
Right.
so it's like cold plasma is the
Oh.
voltage, right?
Cold plasma is just basically atoms that have been cooled down after you strip their electrons free.
Okay, and that would be, and the electrons
They
free would
still have a very, well, I was gonna say they still have a very high affinity to stripping electrons off of anything they come into contact with, so you can use them for like like basically cold burning through material, like a plasma cutter that doesn't produce much heat, but it can still rip the atoms off of whatever it is you're blasting it with, because they're sharing electrons with the the atoms that you're slamming into, since they don't have any and they need them to finish balancing back out. So
Yeah, I mean, because I've heard when I was reading about, I thought only like X-rays and gamma rays were the strong enough to bump off electrons off like DNA to cause cancer, and they said that anything else would just be a heating up, anything below that. But it's not true. Like certain lower frequencies can be strong enough in energy to bump off electrons. So, right? If that's my assumption's correct, right?
I'm not sure. I know there's probably a lot of confusion too when people are talking about cancer and plasma, because you've got plasma state of a matter, and then you've got plasma as in like the material that blood cells are carried through. So if someone makes this simple, confusion of those two while they're trying to explain something, somebody else could end up with completely the wrong idea of what they're trying to say.
Yes. Well, I study bio stuff, so like I'm getting to where I can like learn how to use a cell phone to like monitor all the body's vital signals. And I mean, I got several experiments I'm running, but I'm getting a lot of data material from like PubMed and it's NHBI or NHBL.com, whatever, .gov or whatever it is, just like, and just trying to figure out like how I can use this the signal analysis where like the oscilloscope waves are, where it's going up and down, and then like it would have all the other frequencies like overlap the one of the signals, because you got like your waveguides when you have like Berlin cells that would monitor the spherical model of reflections, but I don't know if that's very accurate or exact enough to like measure as much as the one with where it's just like an oscilloscope type layout, where the signals overlap. Like that one's more accurate than I'm talking about math now, but all I'm saying is that I'm trying to use the cell phone to do that, as regular signals analysis, because I found articles that they just now recently said that they're experimenting with stuff that's beyond the bandwidth limit of the device or whatever, like they're trying to predict how they can get all the information of signals, past that, and like predict, correctly if they got it exact or not. Like the applications of that would be just phenomenal. Like it sounds like they're doing it right. And like there's a guy that the Raymond Royal Rife scope, he supposedly had grinded the crystals to certain length to where he would say like he'd take the reference beam and the evidence beam that hits the object, and then he would cross phase those, and the exact, like, I guess, opposite phase of the evidence beam, which is the reference beam, and they would even out, any loss in the wave interference, correctly. And then he would extend the resolution past the bandwidth limit, that he sent the evidence signal to go any further, so that's why he was able to, like, scan the actual living plasma from, we're talking bioplasma or whatever, like, the glowing part of the cell or whatever, instead of it just being dead material, when he was using, like regular electron microscopes do, so they only see like dead material or material that's, like looking at a rock. But with his method, he was able to see stuff that was glowing. So, I'm just giving like a layman terminology. So, but that's what I'm kind of theoretically trying to do with like the cell phone, or other novel methods without using like big atomic interferometers or mass spectrometry equipment and stuff. So just cost effective. And some people have been experimenting with the cell phone, as a measuring device for stuff like this. There's articles I managed to get. So, but I'm not trying to hog the thing or anything. I'm just letting you know all the projects I've been working on. So
hey, Jeremy, there's an app that you can download to make your cell phone into a radiation detector.
Oh, that's cool. Like a Geiger counter?
Like, well, it's like a Geiger counter, but it's not a Geiger counter. And then
Does it measure the thermal radiation that gives off like the temperature, wavelengths?
No,
I think he's talking about EMF radiation.
No, I'm talking about betas. It basically, it just does, not betas, it's gammas and beta.
Gamma and beta decay, right? Like a pressure mediation.
Well, like if you had an old CRT TV, you could put your cell phone with this app up to it and measure beta radiation.
That's pretty cool. I'm thinking that's the Raman spectra, but like
now most of the radiation that you would be detecting will be the gamma sort, which is photons. They're just
now that's cool. That would go hand in hand with my experiment. I've been working with the mandalas.
So now the other thing I was going to tell you is Android operating systems, unlike Apple. Apple, if you want to do an app, you got to pay $100 to get a license. But for the like Android or Samsung type stuff, it's all open source, so you can write your own apps, and there's a lot of software tools on there that are real easy. They're like visual, and so I did an app. I took a class at Cabrillo College, and I used to write software at the beginning of time. Key punch cards. That's what I learned on. But
that's where it's at, man. Like I still think that that's viable today because of the. We'll get back on topic though, but I think.
Yeah, but what I'm saying though is that you can do your own apps, and it's not that hard. I did one where I took at my actual Geiger counter, and it has a audio jack to listen for the clicks. And I plugged it into the audio jack for my cell phone and wrote a little FFT function that like counted up all the counts. And I aced that class because I was the only one in the class that could interface my cell phone to some other measurement device. Because that's how I learned to do it. It was like taking my old 286 computer and hooking it up to my oscilloscope, that kind of stuff. So, well, but you can do all that, and there's a lot of stuff online. Just look for the apps.
Michael, that's very fascinating and relevant info, actually, and you're reminding me kind of what Hutchinson was talking about a couple weeks back, and how they were measuring atoms' sound frequencies through reverse engineering to speakers, and what you're talking, connecting it through that app, I'm thinking would exponentially give their results and their method way more efficiency and resonant frequency measuring of atomic masses and resonant frequencies through sound frequency.
Yeah,
Sound is what, I mean, when you tap on the table, it's creating sound. It's like light, but it behaves differently.
You're trying to like scale the curve gradient that's evenly through all the wave interferences that are going basically, and, so it doesn't jam, but it's like, trying to fit a large wave through the small wave, and that's kind of problematic. That's how I visualize it.
Well, that's what you're doing when you're creating a harmonic, is you're fitting the small wave in the large wave.
Yeah. My experiment, well, not my experiment, but this person, like I said, Nikki Saraswati, Saraswati, that person was experimenting with mandalas to see that it had made chemical changes by the photoelectric effect on objects as far as like ethanol or crystals, like quartz, and as far as like other objects is, I guess, metals that change in oxides and stuff, and then as well as what was another one that the person did? Crap, my mind goes blank. But like beverages like coffee and stuff, see if it changed. But the person was using a chromatography to see the rate and change of syllables. So, and I was looking up chromatography, what it was, because this is something new I'm just looking into. And apparently you have like your stationary phase and your mobile phase, and your mobile phase detects the rates of change in the solubility of the solvents of the whatever your object you're using. So, but they detected ethanol changes in the percentage. I forget how they did it, but they were the mass. They measured the mass of it, and like it decreased by like 2.88%. And apparently that the mandala picture did affect it. So, and they're claiming that they took the oscilloscope and they were detecting gamma radiation coming off of this mandala picture. So,
that's interesting.
Yeah, I got the book, but it's in French. But I'm gonna start testing it. And they said that the person took I think it was a blue topaz crystal, and they left it on one of the mandalas. Supposedly it changed color in the next hour or so to white topaz.
Wow.
So I'm gonna check out, see further about that. That person did not supposedly want to give the information out to mainstream because of whatever deals, but I'm gonna experiment with this myself. They say that these mandala pictures at the Temple of Borobudur in India have some significance with some of the structures, because they said that these things would supposedly resonate with other parts of the buildings, and all those buildings in the cells do kind of have a resonant quality to them. So there might be something to it. I know that's very out there, but
Oh, you got to experiment. Failure's not an option. It's a learning experience.
Oh yeah, definitely. And this.
Oh, hey, Bernie, I sent you that email that I asked you for your email. I sent you an email. Pardon me.
Thank you, my friend. Appreciate it.
Yeah. Go ahead.
No, you go ahead.
Yeah, the Shugnite, I got that from Dan Winter. So like I'm a big
I know Dan Winter.
Yeah, Dan Winter, it's exactly what he's explaining is what everyone's looking for, as far as the wave interferometer,
There's some
perfect
good
resonance.
info with the monoatomics and plasmoids and stuff.
Yeah, he knows
like that.
all about that. He's a good source for that. I
And
agree.
then his fractal geometry is another really, really good one with
Yeah.
the phi ratio and whatnot.
Yeah, I was trying to see if there's much relevance to it. I mean, it's buying me into it, but I want to test it. You know,
Yeah, well, that's it. Test it. If you can't reproduce it regularly, nobody's gonna give it much credence.
No.
Is that the Shung? I think it's Shungite from Shunga in Russia, or Shunga, or whatever you say.
Oh yeah.
No, that's how I learned it in my geology class. That's why I was laughing.
Yeah,
I was like,
he said it.
oh my goodness, LA.
It negated radiation of some sort.
Yeah,
like
it's supposed to filter out EMF. For a while, they were selling little tiny things that you would like put in your wallet and stuff. I remember this is like way back. This is like in the 80s.
Oh yeah. Yeah, definitely. I mean, shoot, but
it was
that's
like
interesting.
EMF stuff, and there is a real problem with electromagnetic fields. We have what's called electrosmog. If you live in cities where there's all these Wi-Fi, you go to hook up to Wi-Fi and there's 20,000 Wi-Fis.
Yeah, I know.
That's what they call electrosmog. It's a type of smog, and it's bad.
Modulating your DNA and everything. Yeah.
It's bad for cells. I mean, it's like your microwave oven is what, 2.6 gigahertz. It cooks water fine.
Yeah, definitely.
So I mean, the long-term exposure to low levels of this kind of radiation is harmful to biological systems.
Oh,
and there's
definitely.
some people that are very sensitive to it, that get sick.
Yeah.
And they
like
have to go. They have to go live where the radio telescopes are, because that's the only place that's safe for them to live. Because they have, and where the radio telescopes are, they can't have any EMF.
Yeah, it's like a calm for them, where everywhere else,
Yeah.
it's like the static is like screaming noise to them.
Oh yeah, they
crushing migraines, all sorts of stuff.
Harmful to them. I know people that have actually died from this shit. So.
Oh yeah. Hey, well, I got something that I could share with you, Bernard. I'm trying to look it up. This guy, like, he made gold darn it, copper turned to silver and silver turned to gold, like the nanoparticle.
Oh yeah, that's Bernie. He's the alchemist.
I believe that I've actually produced some of those results myself, but they transmuted back in after about 3 months of being sealed within the reactions, and that through Isaac Newton's writings and my own upcoming theory that I will release of how to do it on a more stable level, but it's cold fusion through electrolysis and merging of ancient alchemy. And it's very advanced, Isaac Newton's descriptions. I highly recommend people give them a reading, because it's like, it's the missing connection of his light, color, sound, relativity to the other aspects of it, and that this electrolysis, alchemy, electric chemistry is this missing cold fusion of nature sort of energy and technology.
There's this guy that was like said rubbing the silver onto the I think it was silver onto object, but he used to experiment with phonon resonance, and he said that he made the nano particulates of the silver turn to gold. I have this PDF. It actually explains like all the hertz, slash centimeters.
Definitely, if you can post the PDF in the chat right now, I would love
Yeah, yeah, you might want to check that out. I got a YouTube channel of his. I'm trying to figure this out. Hold on a second.
For sure.
I think it's kind of cool that Newton, this guy who he basically came up with calculus, which I hated.
Well,
And he was an
yeah.
alchemist, you know?
Yeah. Well, I'm
It's
against
like,
that.
who would ever have thought that this is like the founder of modern science?
Right? These million words of writing and his science work just weren't released to anybody or the public for how many hundreds of years to his death, and they only came public 2 or 3 years ago where they started getting the translations finally.
Yeah, I actually have access to that. I don't remember where. It's unpublished, stuff, but I think everybody can get it. Trying to figure out how to post a PDF in this. And
Just in the the chat on the side there. I'm just gonna give you guys a quick little brief nonsense demo. See where like this one where it's got the gold nano plated on the side,
Yeah.
or where the gold is turned a can't really see it, but it's a purple in this one.
there we go.
Or more also gold on top and then a little purple on the bottom.
Yeah, okay, I can see that.
And then so this one where it's the blue or the green where it's oxidized.
Huh?
Where the red, which could be a mercury oxide, but that'd be mass transmutation if this is mercury, because it was made, this one specifically, out of copper. But it's that when any of these monoatomics go from the pure white single atom, when it's in that plasma state, that is where you're able to get the health effects from it or the superconductive effects of it. But as soon as you just add that one oxygen to it, where it's now bonded with another particle, that's where you're instantly going to start accumulating your heavy metal toxic poisoning. And it's because it's not a single little plasma element that can go through and resonate with your cells. Instead, it's now this particle solid that's tearing into, getting stuck, and then damaging.
So I got a question for you, Bernie. Does that mean that this is a process that you could use to, say, decontaminate sites? For example, like where there's heavy metal
100%, Boyd. I don't know if you've looked into the Keshe Foundation's work, but over the last 10 years, they've done, and they were doing some research in Japan and had some success with Fukushima directly, where there's an offshoot company created.
They're taking radioisotopes and decontaminating them, right?
Yeah. And then I believe Hutchinson was also mentioning something.
Oh yeah, that's right. He did talk about that.
Yeah.
That's a good point.
A lot of
That's really cool. That's really cool.
So, but yeah, the main points though being, it's like, even if it's just like the solid, like single atom, but it's gold, you don't want any material matter whatsoever that is other than the straight white, because as soon as you get it oxidized or any other particle, that's where you instantly start getting negative effects instead of the positive health effects, and will very quickly, very shortly, even absorb these oxide, so the copper oxide dust or the gold oxide dust or whatnot, that's like the blue-green out of it, that's then going into your body and then accumulating in mass on that heavy metal poisoning side of it, as opposed to if it's just the pure.
How do you oxidize gold, Bernie?
It adds up to it.
How do you oxidize gold?
So all of these elements, and I've had, and I'll show you one jar where it is just gold on gold, but it's that I'm using in the electrolysis both the same metals on the cathode and the anodes when I'm making the specific pure monoatomics of those elements, and that if you create it in a stable amount, it will always forever stay in this white pure. Or if for any reason you change like a frequency of electric or just
a contaminant would cause it to change.
Anything, then it starts to oxidize on its own, turn to the green, blue, or it'll start turning to the red.
Do you have any Any of your samples with oxidation for gold?
Yeah, yes, I do. I've got several where the gold's directly gone from the white to the blue gold.
Wow. Wow, that's cool stuff.
Actually, give
Thanks
me.
for sharing.
Yeah, no worries, my friend.
Bernie, on theory in transmutation, could quantum tunneling be a factor in how this works? Because if so, say in the electrolysis experiments, this would seem to be a case of a unified field theory, right? Where because quantum tunneling is about the gravitational kind of architecture of space-time, even on a small scale, versus the electromagnetic theory of electrolysis. Do you see this in your analysis?
Yeah, what
how
you're
do we
saying
get
definitely would make sense in like a major part of connecting it on the higher dimensional dynamic bridge of the interworkings of it and connecting it to the multiverse for sure. It is the gap that you get that resonant frequency of that element down to that vibrational or resonating harmonic just energy or frequency, then you're able from that point to do exactly what you just said. And it takes just the smallest amount of energy to shift a whole bunch of that matter. Then, for instance, when I have some of the stuff that is like in the pure monoatomic, and I'll cut off the anode side of it and cut off the red wire going into it, simultaneously all of the white monoatomic instantly turns yellow into what the alchemists say is their sulfur oxide or something like that. But it's that it's resonating on that all that plasma matter or whatnot that would be neutral simultaneously with just the smallest little tiniest change of energy can have that huge effect of it. And that would be some sort of quantum tunneling like you're talking about, for sure.
It's almost like a chain reaction. You know what I mean?
Absolutely. And it's that what's fascinated me is how many different times and how many different types of reactions have happened with no chemical reaction change at all. And it'll just be like the slightest either temperature or just voltage or reversal of the electrical feed or something like that, that will then have these mass effects on the overall dynamic system. I've got lots of pictures of it, but I'll put together, maybe Micah, if we could talk sometime and you could help me go through lots of my photographic evidence of my experiments, help me put together a presentation for it.
That would be cool.
One of my other experiments I'm going to try is with using my cell phone. I found a video how to turn my camera sensor into a nano measurement size detector that can detect like brain oscillation or fluctuations, like as far as like the neurosynapse firings and stuff. And I forget the name of it, but it was like optogenetic modulation or photobiomodulation. But I can use the camera sensor to actually modulate the brain frequencies without needing an EEG cap or any connector source, and it will even despite the temperature.
How does that do that with the RF radiation?
Yes, but like it could even detect more than just the RF radiation. Like it would detect like the light, like fiber optic cables, how the light transfers, through at that I guess at the nano measurement. So, photonics, goes at the nanometer, right? So, or close to it.
Protons are a million times smaller than a nanometer.
Oh, okay.
They're femtometers. Femtos 10 to the minus 15.
Attoseconds to femto.
Nano is 10 to the minus 9.
Okay.
So you could fit a
except that-
whole lot of protons in a nanometer.
Okay. Well, they said that this camera sensor, that the way they did it in this video, you can use to detect all the oscillations and all the, like it could do what an EEG cap can do and an MRI and everything can do, but better with just using your cell phone sensor. And he showed the lady showed it. It's like it was a new thing they did last year. I have the video. I have to
I
look
hope it
for
wasn't
but-
that lady that got busted for
Oh, I
fraud.
hope not.
You probably read about that,
Making Anna on that.
I probably don't know what you're referring to.
I hope you
but-
didn't invest in it, sir.
No. This
Theranos, right? The scheme to diagnose most diseases from just one small blood sample.
Yeah, that's the one.
Now this would be a dream come true for technology, and the promise may have been deliverable on the genetic analysis front. If you think about it, you could amplify a small sample of blood, but the pathogens present in the
John,
blood.
you're so onto it, and that's actually a next level aspect that I'll be showing in my presentation, and it's that when you add a small amount of your own plasma into these electrolysis reactions when making the monoatomic gold and silver, that it simultaneously starts reproducing your own amino acids on the anode side, bubbling up. No matter where you put your hair, your skin, your blood, your mucus into the reaction, it simultaneously puts up this huge amount of bubbling up of your own amino acids DNA that it's reproducing.
But what if I don't want your DNA?
But well, you only want it on your own, right? And then that's exactly it. Is it's giving you these single atoms or these single nanoparticles that are your specific RNA or RNA DNA.
I could think of a way you could make a cryptocurrency.
But that is your nanoparticle. That is your plasma resonant frequency on a single atom scale. That if you're then able to tie into these plasma metals that are then vibrating on your atomic level, that then that energy should be able to be transferred over to your cells in your body, and theoretically how this colloidal silver, colloidal gold, monoatomic gold would work in the body system.
Goldfinger.
But there's a thing here I'm sharing now with proof of my light photomodulation thing you could do with your cell phone or even a laser. I have this document that tells you can use a laser to modulate like glutamate tissue in your brain to be fired upon, and it would release it and allow like excitation of frequency to perform better in those areas in the brain. And you can just use a pin laser, if you modulate the frequency with whatever mathematical modulation scheme that would do that. That was like using a 3D hologram type stuff. Like I said, I have the articles on it, so I'm just barely learning all this. But I'm sharing this right now. Using light to transform species, Dr. Dezang Kang, again, if I said that right, repeated passages of polarized light with high frequency electromagnetic generator passed through a donor chamber with a duck to acceptor chamber with pregnant mother hen. It said the result was a hybrid chick duck with flat beaks, longer neck, webbing between toes, and large internal organs. And it said a repeat of experiment with 500 eggs, 480 chicks hatched. And it said 80% had flat bills, 90% had eyes moved to a position similar to ducks.
Jeremy,
25%.
sorry, just what's the relevance of this duck breeding? I'm only interrupting because my buddy Mike with Faraday is back, and I think he's got a demo he wants to show of one of his motors.
Oh, sure. Yeah, I want to. Basically,
Actually,
it's light. It's basically light energy be used to affect information DNA that is transmitted to future generations. So they used a green laser through salamander eggs and then redirected into frog eggs, and the result was salamanders hatched from the frog eggs. So it was using light to transform species. So and this is by Dr. Peter Gararev. So like photomodulation can use the DNA's encoded information, like, you know, and you can actually literally change another entity or whatever, you know, in real time, probably transform it depending on the delay time and, you know, the phase shift. So it kind of goes back to the Montauk project and the Philadelphia experiment. So this is kind of like a proof of it, but with tissue.
Maybe that's what happened to be.
No, but this is
There
proof
may
of
be
it.
some fairly serious bioethics issues there with animal experimentation of a relatively drastic sort. I'm not sure what theoretical analysis they had done ahead of time for say for the safety of these animal experiments, but right, it might not. Some of this stuff might be a little bit questionable on an ethical front.
Oh yeah, definitely. But this proves that everything has its information hologram code, which is, you know, the wave interactions modeled, you know, wave interference nodes, and, you know, that makes the hologram, and that's your information code, and you can use that to change, add something to else to change it to, you know, similar stuff. So this is like just a proof of it, and these are the two scientists that did it. So I'm sharing it on the thing.
Reminds
So.
me of reminiscent of Rupert Sheldrake's work.
Oh yeah, the morphogenic field. Yeah. But I want to be quiet now because you said that Mark Faraday had something to, you know, something.
Yeah, so I was talking earlier about the end machine. Here it is. So I 3D printed everything. I use high definition 3D printer. I'm using ceramic seated bearings. The only thing that's conductive are the two neodymium magnets inside the shaft, and then I got the two pickup brushes on the ends here. That's where you would pick up your amperage. So when I hook up a DC motor to it and I spin it at about 4,000 RPM, I get about 25 to 30 amps. Now, the original end machine by Bruce Tupama basically was a very large version of this. This is a miniature version of what he did. So the neodymium magnets, north poles are facing out, negative to the center. So when I did the
what's the input power?
Input power is just a regular DC motor that can do about 4,000 RPM.
And what's that motor power? How much power does it take to turn the motor?
To run it at 4,000 RPMs, it'd be about 10 watts.
So
give or take.
It's 120 volts. So I guess what I'm asking is, how much power are you getting out compared to how much power are you getting in?
Well, that's the thing. That's where Bruce Tupama kind of failed to prove the over unity of this machine, because you're getting a huge amount of current coming out of this, but very, very small voltage. Okay. So his machine was, I believe, about 800 pounds. So
no, I'm asking you about yours because see, this is with all these lightweight components. You've solved a problem that he didn't have a way to solve. You've got
the
lighter motor, right?
Yeah, it's a
so
lot
I'm
more.
Asking in this case, this experiment you're doing, just guesstimate how much power are you putting into what you're getting out?
Well,
I mean, you could figure it out. It's 120 volt motor, right?
Well, I'm using a DC motor.
Oh, DC. What is how many volts?
12 volts at I believe it was about 1 amp. So about 12 watts, say.
So 12 watts in, and you got
right now. This is where the problem is. Okay, you can get a huge amount of amperage out, but when it comes to the voltage potential, it's in the microvolts. That's the same problem that Bruce Tupama had. Okay, so he built a very, very large version of this where he was able to get 80 volts DC at 2,500 amps. Okay, so you would have
it up. hook it up to a little power amplifier that you can buy at the heart.
Well, see, this is what I believe Peter Linderman was working on this years ago, back in the early 80s, when he was with Borderland Sciences. So what they did was they actually sectioned off the magnets. So it wouldn't be like a solid magnet all the way around. It would be sectionals, like almost like pie shape.
And would
all
they
the way
go
around.
opposite? Would they?
No, it was the same poles all the way around, but what they did was they turned it basically into an oscillating current, put that through a step-up transformer, and then the results changed. That was the only way they were able to get the voltage where, you know, they had all the amps in the world to work with, but no voltage. So
They had to modulate the amperage somehow.
That's right. They had to make that magnetic field into an AC oscillating current in order to get the voltage out.
Well, it's electromagnetic field you're talking about.
Right.
It's not the magnets. It's not a permanent magnet.
That's why they had to do each magnet in a pie shape.
So couldn't you make that with like permanent magnets?
Yeah, you could do it. You'd have to get the magnet specially cut to do what I want to do. It can be done. There's a company actually not too far from me that could probably do it.
Because maybe that's the problem. You're trying to use an electromagnet and you need a permanent magnet.
Well, these are permanent magnets, which I have in here now. They're, you know, those giant fishing magnets.
Right, but they're all the same direction.
That's right.
But you could get that cut up, couldn't you?
Yeah, I could probably go to that company and they could probably do a special order for me, and I would have to give them a schematic what I need.
Back together.
But what I was talking about earlier in the show was the fact that when I hit this thing with high voltage on the shaft, on the shaft, I hit it with 6 kVA, the things start to run across the table.
Oh, I see. Which direction?
Let's see, look at it this way. It always went to the left for some reason, always to the left. So that would be
the drive. So which side had the drive motor on it?
Drive motors here.
Okay, and so when you put, and then on the other side, when you put a high voltage on the other side here.
Right.
You put 5 kV or something. Is that what you said?
5 to 6 kVA. Yep.
Okay. On that
question.
Then it started to move in the direction of the point where you were applying the high voltage, correct?
Correct.
Well,
So
more
that was-
importantly, you said it kept going the same direction.
Yes.
Can you get a level and like something that can really tell minute differences in angle and check the table at signal and make sure one side is not just slightly lower than the other? Because if you vibrate something and there's any kind of gradation, even if you can't see it, it'll slowly go boop, 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 and work its way down. It's what I noticed about the EM drive. They had it on a spindle, and they have this AC transformer built into the whole thing, right? Well, the AC transformer, if you've ever stood near one, they make a zzz.
Yeah, they buzz.
They're vibrating. And have you ever seen a pager that's kind of bubbled because the battery got damaged, and it swells up to make the bottom kind of rounded, and when it vibrates, it'll go and keep spinning around in a circle?
Right.
You know, no wonder they were getting rotational energy, because they were vibrating the whole thing. And it was just because of the angle of whatever it was that was tilted, causing it to rotate in that angle.
Right. See, with my device, I did 2 tests. One with the voltage. It would vibrate a little bit, but not very much, because I got this thing pretty balanced. I've engineered it really, really good, to the point I had very, very little vibration even from the motor. But the second I added the voltage, that's where the anomaly happened.
Right. And I was going to say, that means that basically the waveform that you're putting in that, you said KVA, right?
Yes, 5 to 6,000 volts. Yeah.
So, but this is AC voltage you're pulsing into it, or pulsed DC?
It's a pulse DC.
Okay, pulses though, which means that you're generating vibration.
Now,
because you're shifting all of the electrons in the atoms on a regular time scale back forward, then letting them relax, then forward, then letting them relax, then
Right.
forward, then letting them relax.
And
That
it's got a
creates the whole
hysteresis,
thing.
so it's gonna take a while. It's
That's
gonna have
true.
a built natural.
That depends on how much time delay between each pulse there is. Because if
Yeah,
there's not
see-
enough and it retains that, then it's going to reduce the amount, but you're still always going to have a diminishment on the hysteresis. Hysteresis is not
Right.
100%, like it won't
Yeah,
hold 100%.
yeah.
It immediately starts losing. So you're
Right.
just looking at like smaller and smaller hills, the
like
more
this.
See,
hysteresis there is.
yeah, the frequency
So-
is about 43 kilocycles.
Okay. So that,
So
that's
it's
still a frequency. And here's the thing. Your vibration rate is still higher than the diameter of your individual atoms, meaning there's more than enough energy to cause it to lift off, then drop on the next and roll down over. And if you look at atomic structures on that level, you're literally looking at millions of little tiny ball bearings jammed together. So any
Right.
vibration is going to cause it to go just slide right down that thing.
Yeah, I just thought it was kind of odd.
So you measured that the platform that your apparatus was totally level?
Yeah, oh yeah, it was a level table, yeah. And it was a solid pine, so.
Even when was it level, even when you were applying that high voltage and
Yeah,
had
same,
everything else?
yep, all the whole setup was exactly the same. Yeah.
Would you put a force gauge on the opposite side of the table to measure how much pull it had on it?
Honestly, at that time, I'm working on energy devices. I wasn't working on any, gravitic devices at all.
Well, work is
You know what I
energy.
mean? Yeah, no,
That's
it's
what you're
true.
doing. You're doing work. So if you're doing work, you got energy. So can't have
Yeah.
work without energy.
That's right.
You're working with
It's true.
electromagnetic alternative energy, I'm assuming, using
Yeah.
like magnetic structures and electrical generation and
Yeah,
electrical
that's
generation to
more
create
of,
magnetic fields to try to create this. I already have a design for a magnet to magnet, like permanent magnet system that you can either use if it's designed for a generator. It doesn't matter how much power you're pulling out of it because it doesn't create drag the way the cogging effect does whenever you hook your wires up and your magnets are trying to go by, because the magnet and the coil are stationary.
right,
You're only shutting the magnetic field off and then releasing that magnetic field, and the flow past the magnet is not
Yeah.
being interfered, because there's just as much attraction when it's allowed to pass through to the plate that's passing over as there is when it's blocking the field. Right.
See,
The
like
the other well, now hold on. The other aspect is that if it's built in the motor configuration, it'll generate torque, but it'll never give you any electricity. So you build two of these and tie them together, you can have continuous power that's coming from literally thermal energy is where it's coming from. The thermal energy causing the minute vibrations in the material that the magnets are made out of are causing electron exchange through a crystalline structure that keeps generating an electromagnetic response on an atomic level.
right.
So
See,
if you look at a neodymium magnet, right, on the atomic scale, every single chunk that is a magnetic field is literally 7 iron atoms in a ferromagnetic state on either side of a boron atom that creates a diamagnetic reflection into the iron to increase its magnetic field. Like you're literally taking all of its energy and forcing it back into it and back out the other ends, and then it's capped off on the ends by 2 paramagnetic magnetic lenses of 2 neodymium atoms. And then you start stacking those together. As long as the electrons can be shared through the crystal structure, you get this massive amount of power. The second you break that crystalline electromagnetic or the electron exchange, like say a nickel plating or coating it with like epoxy or something like that, now you start getting a diminishing return, because you've only got a little bit of the energy plus the energy in the next magnet that you can increase that amount of magnetic energy. You remove that material between the two and jam the two together. Now you massively increase the magnetic output of the whole thing, because you're allowing those electrons to travel all the way through the entirety of the material from one side to the other.
Right. And basically from the axle out. So all the magnetic flux is being forced to the leading edge, and that's where I pick up the amps off the leading edge of the magnet. So
well, have you used magnetic structure, permanent magnetic structure isolation and made the mistake of looking at it like you're redirecting the magnetic field, or are you aware that it's actually absorption and either focus or diminishment spread out in order to limit the magnetic field and then increase the magnetic field? Because that's the one thing I see everybody makes. They think if you put a shield around it and you have the north facing this way or that way, and then you rotate it, that it changes the angle that it's at, and it's not. It's just diminishing the amount of the bubble that's sticking out of your magnetic shielding. Because a magnetic shield wrapped around a magnet is about like putting a corset around like a balloon and squeezing it. It causes it to pop out the ends. So you're rolling across that bubble constantly. You can reduce the amount of bubble by rotating it, but it's still a bubble. So that means you still got as much rise as you got fall. So you're not gaining any ground, right? But when you have a magnetic field entering into what's considered a magnetic shield that's very small and long, it will poke out the other end of the shield, right? So kind of like when you take a magnet and you stick it to like a paper clip and then use that paper clip to pick up another paper clip.
Right.
But if you have a flat plate with layers that create a reversal on each other, you can take that magnetic field that's hitting that plate and have it soak into
you're
flat
bang
plane.
on, Thomas, and it has to. That's like the nano layers of these monoatomics when they crystalline, and then it's these single layered.
Well, you're talking about materials though that are hard to make. It's real easy.
I'm proving
listen,
really
for
easy to
magnetic
make.
structure, it's really easy to just take some steel sheet and some solid bismuth and some rosin flux and just pin the surface of it and then stack those up.
Yeah, exactly.
Anybody
And
can do
what
that.
I'm saying is through this electrolysis process that I'm finding is that it's actually a very cheap and easy way to make these layers to start being able to then do exactly what you're talking about and applying.
The thing you're deep into, I wonder if you could do some digging and try to come up with an effective way to electroplate bismuth.
Yeah, I've got a few experiments I've done with bismuth, and it's
everything I've done, it puts like a black powder coating on anything. And all the research I've done, you have to work with bismuth chloride, which is really hard to maintain. Because the second it comes into contact with water, it turns straight into bismuth oxychloride, which is
guys,
like a mother of pearl look.
I'm going to sign off. It's been fun.
For sure, yeah. It's about time to get ending here. I'm gonna have to with Mike. Boyd, we'll talk here in the next few days, but get Faraday, Mike, and myself to do a presentation with Tim here, where we can actually do some scheduled, organized revelations of what we're working with and discovering here.
Right.
Okay, thanks.
Yeah, I was gonna say the reason I backed out of the magnetic stuff was because I found a much more effective means of that thermal harvesting through airflow static. Air is always moving at 700 miles per hour, all the gas particles. So if you have two layers of material that can collect electrons or give away electrons to air that's bouncing back and forth between them, you can have as much energy as you want. And this is the thing, it's strictly thermal energy. And we're not talking about thermal flow, we're talking about the thermal mass that's within a volume. Even if it's completely evenly thermally mated, those gas particles have to be moving at 700 miles per hour in order to create that 1 ton per square meter of pressure that you get out of a gas particle. Otherwise, it becomes a liquid. So anything that stays in that gas particle state, man, you got tons of energy that can even be pulled out of just minute amounts of thermal energy.
Yeah, could I just add something? I did the experiment. I used to test a plasma ball, and I get these plates on either side of the plasma ball, and I tap off it, and I can light up, regular light bulbs with the plasma. So I'm creating that flux field, and I'm finding the plates itself are acting like not a dielectric, but as a capacitor. And that flux field is immersing itself into that metal, and I'm able to extract that. Now, here's the beauty part. I could put 15 of those plates and extract it 15 times and get the same power with the same power input.
Have you thought about changing the shape in order to basically concentrate it?
Yeah.
Because the metal you're working with that the magnetic field is hitting.
Yeah.
The structure shape difference doesn't look the same, or the shape doesn't look the same as it does with a lensing system for lighting, but you can get metal to focus a magnetic field or to diffuse it.
Yeah. So when I was actually, I have an idea that I was going to make a miniature version of a Dyson sphere using the plasma ball in the middle.
Is Mark around? I'm trying to actually share, but it won't let me right now. Your one of your videos, Mike, of exactly what you're trying to describe that you have up on your channel.
Yeah. So what I was thinking is setting up a rig that would kind of emulate what a Dyson sphere would be. The plasma ball be in the middle, and then I would create this fake globe around it and put the plates in strategic areas all around the plasma ball and extract all the power from there. So there would be like maybe a 1/4 inch gap between the plasma ball glass and the actual outside cage, I guess you could say I would be building on the outside. But like I said, the more plates you add to it, you're multiplying the power.
I really need to put you in contact with Shaziz. He's been working with plasma-based technology for quite a while for alternative energy purposes.
Yeah, plasma. I'm finding more and more. Yeah, I'm finding plasma is a really interesting field to be in because the fact that I could light up stuff from several feet away with such little power.
I'm still waiting for somebody to figure out that you can use.
There it is, Bernie.
What is it? Shape. Use the same effect with magnetic fields that you get for like the nuclear explosion. They had to use shaped charges in order to create a concave pressure rather than a convex pressure, because the convex pressure created weak points in the wall pressing in that all of the pressure would escape through before they could hit critical mass. But the concave based explosions inward, there was no weak point around the edges before it hit critical mass. And if you could do the same thing with magnetic fields, you could probably hit that critical mass for fusion that you're needing to maintain that plasma.
Yeah, I find the bigger, I'm finding the bigger the plates are too, more of that magnetic flux adheres to the plate and actually acts as essentially like a capacitor. A high voltage capacitor.
I would say I think the secret to the magnetically shaped charge is in what Michael was talking about with the hysteresis, using different hysteresis rate materials in your system.
Right. So like say like even like a graphene type shielded like a spray on the metal plate itself would actually turn that plate into like a capacitor, right? And store that power, not only collect the power, but it actually stores it at the same time.
Graphene is definitely something that we need to get a lock on, an easier method to manufacture, because I believe that is going to be the secret to fully unlocking the potential of the electrostatic from atmospheric momentum.
Electricity. Yeah.
Because there's well, this is the thing. If you work with two disparate materials like urethane, which has a high positive polaric state when it comes to triboelectric generation, and then Teflon, which has an extremely high negative triboelectric state, you don't want to modify that triboelectric state with something you're covering to collect your electricity, and all metals will. But carbon is completely neutral. So if you put a fine layer of conductive carbon over the surface of that, the gas particles striking the carbon of that graphene will transfer or pick up their electrostatic energy from the material that the carbon is coating, because it'll be like if you've got it coating.
It's like a dielectric.
Teflon, well, no, if you
sorry guys, just to interject quickly, I kept trying to load your video there, Mike, but because I'm running StreamYard and Zoom simultaneously, it's screwing me over. Can somebody else I posted the link of Mike's work there, specifically what you guys are talking about in the chat. If someone else can just open it on YouTube and then share it, it should work properly.
Yeah, I think the significant part of the actual experiment is the fact that you can add as many plates as you want in that field, and you can multiply the power without any extra power input. I think that's the significance of that experiment. So you could put 15, 20, 30 plates, as long as it's picking up that field, that static field that the plasma ball's emitting, you can just keep adding light bulbs and keep adding them, because you don't have to add any extra power to the system.
That's the signal gain, right? When the amplitudes are evenly constructively on each other, right?
Yeah, well, each plate is isolated from each other. All right.
Okay.
Now, if you ground that plate, it kills it. So it's got to be basically totally isolated, one wire coming off. So I've been actually able to light light bulbs with one wire. I don't need a ground. But as soon as I introduce a ground to the circuit, the amount of amperage increases quite a bit. So it's actually taking a lot of the power from the ground as well. But I can light light bulbs with one wire.
Okay, pretty cool. Now I was just trying to figure out, like, 'cause like I said, I'm in the signal analysis, so I'm just basically going off like a Fourier series type thing, like that one guy was saying. Can't remember his name. He mentioned it earlier.
Bruce De Palma, or
Shoot. I don't remember. He was like, it could be Bruce De Palma, but
oh,
remind
Adam
me.
Tremblay was doing it as well.
Yeah, I think
he
he was
was
talking about it. Yeah,
Yeah, Adam Tremblay. Yeah, he was working on it. He was actually stopped by the U.S. government, and he was suppressed pretty badly. So he kind of dropped off.
Hey everybody, welcome back to
No,
Faraday
that's not it,
Research.
Bernie.
It's
That's
Thursday
not
night,
it, Bernie.
or actually Wednesday night, sorry. Yeah,
that's
if you
not it, Bernie.
haven't subscribed to my channel, bottom right-hand corner, all the links are in the description for my Patreon and also
I
my
don't know.
PayPal.
I'm trying. So,
you can
Mike,
donate
if you
there.
can find the right
thank
one
you
to play, it would be
Yeah, it's
all
not
those
it.
people that donated to my channel.
Yeah, you'll see the plasma ball on the screen. You had it earlier, but you didn't bring it up.
Well, Bernie's dad made a plasma ball. I remember that circuit board thing he constructed. It had like a purple gas, like emitting from on the top, and it played the FM radio, whichever.
Oh,
was,
right, yeah.
was charged. Yeah, that was cool. I always, and that solved the UFO thing where they create those plasma balls. Supposedly, you hear rumors of these like purple energy spheres where they start hearing like different sounds and transmission. Like that's probably how they do it. So.
Well, I think plasma is definitely something that they're using in their craft. I could be wrong, but
no. Well, these are pure energy, that they're using to even broadcast, sounds through. It's not even a craft. It's like like a hologram based thing, but it's not a hologram. It's made of pure, plasmatic electricity, bunched together or whatever,
Right.
So, yeah.
Hold on, I just want to show. This is one of the transformers I'm working with right now. This one's a beast. This thing weighs like 25 pounds. It's like unbelievably heavy. So this one here, I was able to patch in on this wire here, and I had 3 outputs. But the thing is, I had 37 watts going out, but I only had 12 watts going in. So I didn't have to pull any more power, and I'm getting 3 times more output with this toroid. That's with the Don Smith generator.
So that's essentially through magnetic induction of the transformer that you're able to get that.
Well, it's holding the flux inside the transformer. So when I actually disconnected the power source and I started fiddling with a couple of the other wires, I got shocked. So it's holding a capacitance within the core. Now, because it's a toroidal, there's no beginning, no end. So that magnetic flux, the field of the magnetic field is trapped, not like an open-end coil where it could go out and disappear, where in the toroid, there's no beginning, there's no end, it's trapped within itself. So that field takes longer to collapse. But that would explain why, when the power was already off, I still got shocked, because that field was still trapped in the core. Enough to give me a good lifter, but nothing lethal. But yeah, that's just some of the stuff I'm working on right now. This thing's a beast, absolute beast. It's 6-inch diameter, and it's about 1.5 inches thick.
You have something to say, or you're muted there, brother? I saw your lips mute, or you're talking to your YouTube channel.
You talking to me, Bernie, or
The alien scientist there.
oh,
There.
oh, Jeremy?
Hey, what's up?
There you are, brother. How you doing, my friend?
How's it going? Sorry, I didn't hear the question. I'm doing a bunch of other stuff. I had the volume turned down, so I'm just I got a couple of things I'm working on.
Yeah, did you see the end machine I was working on, Jeremy?
Yeah, I saw you holding that. That's
Yeah.
interesting.
Yeah, so it's
Experiment.
ceramic bearings. The only thing that's conductive on it are the two neodymium magnets, the shaft, and then the pickup brushes on the ends. And yeah, I was getting about 25 amps coming off this thing, but very, very little voltage, in the microvolts. But Bruce De Palma's machine was about 800 pounds, so he was getting a lot more on the output too. Plus, he was using his contacts were mercury, so he was using some toxic material to actually make like a frictionless type brush.
So since we're in open discussion now, I had a couple things I wanted to bring up earlier, but I was busy putting my kid to bed, so I wasn't available. But you guys can see my screen. Mike McCulloch, he's as you know, he's got a couple DARPA contracts going on over there in the UK, and he posted this on Twitter recently. He said, "I cannot say why here, but I'm in a happy haze period. Bad news travels fast. Good news has NDAs, smiley face." So I thought that was super interesting, because that's one of the groups that has DARPA contracts for, what we call anti-gravity research, or, alternative propulsion research. And, he's definitely one of the people we watch. So when he said that, March 10th, a couple days ago, 3 days ago now, I took notice. I took a screenshot of it. I just wanted to show it here, so we have it on record here in channel 2.
So we have people watching.
I have a question
Yeah.
about that. The one dimensional of the nanomaterials, like is that one dimensional like even lower than, like, I guess you could say your computer screen is like the interface with the, is like considered the 2-dimensional? Just out of
Screen is
curiosity.
your 1D level, and then you're adding hyperdimensional fractals into displaying multiple dimensions onto that 1D.
Okay, so your computer interface would be 2D or 1D, and neat. I have an article that's experimenting with like 2D dimensional stuff that's a little out there, but the guy says that he getting energy harmonics like at the gold frequency and crap, he said something ultraviolet. So I might post it in a second. I'm looking for it, so I'm muting right now. Hold on.
Yeah, it's like I kind of sitting on the sidelines, because everybody's talking about the anti-gravity stuff. I'm more into the energy stuff, but there is correlation. There is kind of this mesh together with energy and anti-gravity, and so yeah, there is a relationship. I'm just kind of focused on the other end.
Right. Yeah. So as far as the energy goes, there's a couple people we should maybe look into getting on here to talk about some of that stuff.
Yeah, I'm actually sorry to cut you off. Yeah, I'm working on another project right now where I'm working on a special battery that basically never runs out of power. So I'm sourcing out the materials for this battery, and I'll be making that soon. A few people out there have made it and have had great success with this
Is that
battery.
in regards to Hutchinson's crystal battery, and then
This one's
something a
slightly
little
different. This one's slightly different. It more stems towards Stubblefield's Earth battery.
Okay.
And yeah, so I've been studying Stubblefield for the last couple of weeks now, and I'm finding some interesting information that actually Tesla was witness to back in the 1800s. He actually went to Stubblefield's farm and witnessed his basically first wireless telephone. So I don't think Tesla was the first. I think Stubblefield was before Tesla, which I didn't know.
Tesla didn't design a lot of the things that people keep attributing to him. He recognized the capability of interfacing these things and bringing them together that the individuals who created them did not.
Right.
So he could bring several minds. He was basically bringing several minds together to create something phenomenally beyond what either one of those minds could produce on their own.
Right. That's why he called it radiant energy. He just took what Stubblefield had and repackaged it and gave it a new name.
Well, he had an ability that a lot of those people didn't have, where he would build something in his head and let it run through a full destructive process real time in his head, and then come back and tear it apart to see what went wrong, what effects it had, how useful it was in different ways and whatnot. That these other people, they could see, you know, a one-dimensional aspect of something they were working at, whereas he's working in full 3D simulation. You know?
You're right.
And running it along the 4-dimensional, you know, time strain that you know, as he lived throughout his life.
Yeah.
So.
Yep. So
that collaboration, I think, is important. That's why I said a research facility where energy, manufacture technology, and the, you know, the travel technology, I'll call it that, because it could be any number of things, would really be useful to put a facility like that together, where all three are working together to come to a single conclusion. So
yeah, because
meaning, you know, pushing all this stuff forward, get it, you know, more advanced.
Yeah, because the anti-gravity needs power, right? And then, you know, it just goes hand in hand together. I think they're one and the same.
Well, like I said, too, you're going to find a lot of evidence in things that you're working on something completely different, that somebody else may go, hey, wait a minute, I've been trying to create that effect there.
Yeah.
The one that you're complaining about that's causing you a problem, I know how to use that. And if we learn how to use it, I might be able to figure out how to negate it from what you're doing so that you can get the effect that you're trying to get, you know,
right.
Piece of the puzzle fitting together, basically. So,
yep.
I still think, though, that it needs to be designed entirely like the interior of some sort of starship and or a star base, and then broadcast it constantly and, you know, monetize it. That way it can basically pay for its own advancement from the sheer entertainment factor that people get on getting to, you know, peer into things and see what's going on, and they become witnesses,
or giving
without
people
having without straining to do so.
With
like I said, if you got all these people watching out of entertainment, they're all witnesses now. You can't silence a million witnesses, you know. So
exactly. It's that if once we are able to figure out even just like some sort of electromagnetic, possibly plasma interaction, electric components, essentially what these free energy devices seem to have the potential of, but just like if it's reducing people's electrical load off of their house by 30% or 40% in this day and time, that's a lot of both green energy that, you know, is not going to be taken out of the ground in oil or disasters, anything like that. And
but hey, you should get a little more simple. They're not concerned about taking oil out of the ground.
No,
you know
no,
what the real concern? Anybody who's
about
serious about that, their concern is the heat.
That you plug into your
right,
home,
but their concern is the heat.
Reduces by 30% your electrical load that you're using each month. Then it's going to take 1/3 of your power bill each month. That's huge to a lot of people in this day and age.
Well, imagine going a step further and reducing it by 100%.
Yeah, but one step at a time, right? It's even if you get something that we can make.
Hey, I'm a 2 steps type of person, man. When I'm going up the stairs, I usually take 2 to 3 steps at a time when I'm in a hurry. And that's why I said though, green energy is not green energy. They have a small section that's concerned about the toxicity, but the majority of those people are concerned about the gases that are pumped into the air that are helping trap solar energy so that it cannot escape fast enough, causing the entire planet to raise temperature. No. Listen, this is important. If we find a way to turn static thermal energy into electricity, you're lowering that temperature ratio and you're producing all the power you need.
100%.
You're totally killing 2 birds with 1 stone.
And that's what we're kind of like working on with the Don Smith aspect, the double spark gap, where it's using radiant energy through the plasma of the spark gap arcs. You're talking
about using that to basically crack water to make oxyhydro power.
Yeah, you could do that too. Actually, you don't even have to do that anymore. It's what's his name? Walt Jenkins came up with a new way of coming up with the nanocrystal plasmoids that Kenneth Shoulders was working on in a device that didn't even involve electrolysis at all. As he used these, the machines that you would see that would create like the mist, those mister things, the ultrasonic misters.
Ionized foggers, yeah, exactly.
Yeah, the foggers. So he would take that and he would
mist of actual water. That's the key, is the gas plasmoid is still in its water state. It's not a hydrogen state, it's not an oxygen state.
Right.
The supposed brown gases.
That sounds like something that would benefit from using tuned lasers to basically blast the mist after it comes off of that. Where you're using two frequencies of laser. One targets the oxygen, the other one targets the hydrogen, making it very easy to just pull those two apart.
Well, see, his experiment, he was creating this fog, putting it through a chamber where it gets hit by high voltage. And the high voltage is what was creating the nanocluster plasmoids. And that is the gas that all these guys that are doing those hydrogen generators in their car right now, they're thinking that they're using hydrogen. Well, the real power was actually getting fused in the water. It wasn't actually getting out. So if you cavitate the water, or based on certain aspects of the design of your electrolyzer, you can get those nano clusters out and into the engine. That's where the real power is. It's not the hydrogen. So Walt Jenkins came up with a device that eliminated the electrolysis process completely. It's gone. You don't need it. He created the fog. He hit the fog with the high voltage electricity. That's what went into the engine. So he eliminated, that aspect of.
I'll say I have equipment for lipase experiments. You familiar with that?
No.
It's an acronym for low intensity pulsed ultrasound.
Okay, so basically these things kind of work
teeth.
on this.
Like you get a tooth pulled, it'll activate the stem cells to go, hey, there's a tooth supposed to be here. It's not here, so we're going to turn into dentine cells, and now you have a new tooth.
Well, I got a tooth missing here. Maybe you could help me out.
I have a few. That's part of what got me started. But then I realized that this technology could probably be used if it could be introduced deep enough into the body.
Right.
Because what you're doing when you convert a stem cell into any other type of cell is you're starting with that baby age. Telomeres and all the other components. So it basically has the 80-year lifespan within that cell, starting at ground zero. So if you're at 60 and you replace even 2% of all of your cells with stem cells, they will eventually replicate and replace all the ones as they age out. And you're now at maybe a 20 or 30-year-old age overall physically. Now, if you can get the stem cells to replicate themselves so that you've got baby stem cells always on tap, you're looking at like almost permanent life extension right there. And at that point, then you just be a little more careful, because you might actually, if you don't, screw up and get into an accident that kills you, you could live to 10, 15,000 years. And imagine the accomplishment you could have, not only reaching that age, but also always having that plasticity of mind, where you can always, work on new ideas and invest into new concepts. So
even extending your life, say like 50 years. You know what
Well,
I
that's
mean?
just it. If you extend your lifespan by 50 years, within 50 years, how many life extension techniques will come up?
Exactly.
If you're not
Exactly.
dead yet, you could very well be in that ground zero of never dying of old age.
Yeah,
Pure
immortality.
old age.
Immortal.
So not immortal. Immortal means you can't die. Just age is a
Greatly
disease.
extend it.
Well,
Yeah.
no,
they
age
also-
is a disease. We cure
Right.
that disease, which is much.
Well-
You look at every disease we've got on the planet. The most deadly disease on planet Earth is age, because if you avoid all the other diseases, you're lucky enough to avoid all those, you're guaranteed to get hit by old age.
Right.
You know, so let's cure that one too. That way, basically, we would make it basically one of those things where you, due to lack of aging, will now have to worry about cancer, because eventually you will have to deal with it. So now we better focus on solving the cancer problem too, so that way we don't have that coming along and knocking us out, because, you know, we just don't have the aging process to age us out before we can get hit by that statistical anomaly.
Well, they did research with biophotons to where if more photons accumulate in like the tubulin of DNA, that the rest of it will cause like a chain effect to fix whatever else is needed that's missing, and basically reversing age. So that you should probably, there's tons of research documents on coherent biophotons curing all types of things, including cancer and stuff.
I'm assuming they're looking at a macroorganism scale when they're talking about reversing age, which means it may not be reversing cellular age, it's reversing the organism's age by activating something that is a younger state and bringing in new fresh cells to replace old dead cells. That's what the lipase is doing.
It's
So
even more than that. It's like it creates the components that are not even present that are needed in the body, that from it generates it on its own from previous combinations to make what is next needed down the line from outside, you know, regardless of any external source going in, you know, like any chemical needed, like it produces it on its own, like a self-organizing resonance.
well,
So,
that's what the lipase is doing. You're taking something that's already in your body that has been shut down,
yeah,
so that it can't do the job that it was supposed to do, and busting that halting mechanism off of the genetic code, so that it can now do what it's supposed to do. And as soon as it's activated, it goes, what's missing that I need to now become? So
yeah, so it's basically a frequency resonance is what you're doing, right? You're just trying to find the right modulation. for
right
everything.
frequency to affect the right chemical that's you know, affixed
Yeah,
into the
yeah,
genetic
that's
code,
like
so
the
that it's not interfering with it
that-
anymore.
yeah, that's like the using a laser with the right frequency information to say speed up brain frequency to cause excitation in some neurons, like they did with the glutamate you know, blasting. And it doesn't require much. I'm sharing an article here that is similar to that frequency type thing, where they're talking about information batteries, where they change like the time duty cycles of the computation itself in like circuit boards and regular computers, you know, just by the software and not even the hardware board itself. And they actually managed to decrease actual power needed by 30% to do these, you know, mathematical computations in the circuit board. They actually reduced, you know, excess heat or power required. So it's like the frequency itself is like, you know, the energy source, you know, equivalent, you know, to like biological, you know. So, you know, what I'm trying to say is like, it's like they got I guess these information batteries are like the one-dimensional span, if you know what I'm saying, you know, like it, I guess if you fix the modulation phases, you get more efficiency and power. So this article right here is just proving, you know, like the concept of what I've been, you know, talking about. So, anyways, go ahead. I'm just.
Yeah, guys, I'm gonna have to head out here. It was great to talk to all of you, and yeah, I'll pop on again soon.
Awesome. Thanks. Alex, is that your name, Alex?
No, Mike.
Mike, sorry.
Yeah.
I'm going to be going to bed here soon too, and I'm about to shut the stream down. We're at 7 hours going
Take care,
strong,
guys.
and I'm getting tired. My kid went to bed like 2 hours ago, so he's going to be up at like 5 a.m. and I need to get that sleep in. So cheers all, and great discussion. Awesome time. Lots of cool stuff. I didn't expect that from Riccardo Storti at all with the Bob Lazar thing, and I'm gonna have to get that a hold of that and repost that tomorrow for people who missed that on my little glitch that I had. So I'm gonna try and get that up for you guys as soon as possible. But yeah, thank you all and have a good night, and I'll do an update tomorrow on some stuff too.
Sounds good. Much love, brother. Thank you. And yeah, hopefully we can do a multi-stream together here sometime in the next week or so.
Definitely. All right. Thank you all and have a good night. Peace out.
Much love and respect, y'all.
All right. The stream's ended and I'm gonna dip out. Thank you all. Have a good night.
Anybody still around? Probably not. Might head out.
I'm
Hello?
still here. I don't hear anything.
still here. Oh, okay. So what did you guys think of the stream?
It's interesting sometimes, not interesting sometimes. Some of the talk they were doing wasn't interesting. But
Yeah. So what kind of experiments have you been doing, Glenn? Like what's your main things been about like recently?
well, recently I haven't been doing anything on propulsion, I've been trying to develop a linear motor for a cryo cooler.
Okay.
But Harold, his TARAVEZ, whatever his last name is, he's got an interesting patent out that I'm going to go out and visit him to see. And I'm trying to build a prototype of that myself.
Yeah. I've been looking at different methodologies of trying to understand frequency modulation and different schisms. So it's like either by like images actually generating some type of, field from it. I mean, that supposedly it's been done. I mean, I have actually I could share something on here if I could figure this out. I have to go to web link here. Darn it. Hold on. Trying to figure this out. Like, I like how this can run multiple screens on this. So, all right. No, it's different. Hold on. Trying to find it here. Trying to copy this. Loading slow. Obviously, it's probably because it's. Come on. Let's see. No, this contains the information I'm working on. Let's see. Where is it at? Well, this will explain a lot what I'm doing. If I can find it. Give me a minute. Just bear with me. I'm gonna post it where you'll see it. And, oh, you gotta be kidding. Did it just? No, it's here. Now I have a lot of tabs. I was kind of looking for it. Is that the top? Let's see. Can't even remember. Oh. Okay, I'll just post it right here. Yeah. Let's see. Copy that. Okay, now I found one of the deals here. I want to post it in the. I want to share it so you can see it. See web URL. Post. Okay, there it goes. All right, here. This is cool. Like, this is something I'm working on, or they're worked on back in 2015. But I'm testing it now, and I'm tying it to ESP research and stuff. And I'm trying to. So it's like low gamma ray exposure mandala. This is like, it says right here. This paper carries a study on low dose gamma ray exposure mandala. The objective is to I won't read it all, but it's research terms of phenomenon of will relate to the radiation of color energy and frequency of mandala effects, descriptive properties, matter interaction of gamma radiation. So it talks about the gamma decays and radioisotopes and type stuff, and cosmic ray and high frequency level and rare terrestrial gamma ray flashes. And yeah, so the guy was testing it, and he said that the photoelectric effect is what was having, properties on the objects. So, and he just detected like different energy level changes that decreased by using chromatography. So, like chemistry-based detection, kind of like how they'd use how caffeine had have an effect on the body using, chemical solvents and stuff. And so they said that the objects even had like a different taste and whichever. So like the cool part is they tested the ethanol here. And so it's like, let's see. I don't know if I can move this content still. But the mandala experiment was newly printed. The validation research was witnessed, supported by Professor Dr. R.I.D. Bagas Manabo, or whatever his name. So they had a laboratory chromatograph machine, and the ethanol was distilled from product Japanese beer. Its ethanol count would not be calculated in the chronograph machine. One part of the ethanol was above the mandala for 15 minutes while waiting for the result of the ethanol count, followed by the ethanol treated by the mandala. So the initial state was like 13.17%, and this is what I was trying to mention. Mandala energy has reduced the value to 10.88%, or at a momentum of 2.25%, with a maximum time of 15 minutes, 900 seconds. The reaction was exergonic, so the final state energy level was lower than the initial state. And the energy momentum is calculated based on the following factors, like, and it tells you here, the energy momentum relation and both forms of mass energy relation is the same. And it revealed that the values and its mass was like, 13.7, and mass 2 was 10.88, and time frame was 900 seconds. So, it gives you the calculation of what it did to get that number and everything. So this is like another way to calculate mass reduction with just chemical type style or whatever. So I thought that was pretty cool. And the person gives like the tachyon relativistic theory.
What's the main point of this? I guess I don't understand.
I think it allows to like transmute stuff based off just the pure frequency waves itself. So it's like phase aligning the object to the next stage up the abundance curve, kind of like, Walter Russell's research, where he has that chart and he has that curve line of the different elements going up the table, what it will become next on the chain, ladder go. So like, copper becomes silver, right? At some point, and then silver becomes gold, like through a phase phonon resonance or whatever. Like, yeah, like that, I gave that PDF I was showing people about the phonon resonance, that using an ancient technique where they would take like a aluminum file or close resonance frequency to like the very closest isotope alloy or something, and they would, you would kind of grind it on the other alloy, and the nano particles on the top would change, to the next element because of the resonance being very close. The frequency vibration oscillatory rate being very close, and it would change. So I'm probably all over the place about this, but I think you get the gist of it, right? So it's basically like the idea of this for me is to test if this wave phase align changes an element to a next thing or whatever it be. So kind of like, chemicals in the brain would produce serotonin, and then like the next, chemical elements needed to be combined with, serotonin with other, elements to make the next neurotransmitter chemical that's higher, it kind of like, DMT is very powerful, and it's made up of components that are needed to make it, naturally in the brain. So like, and they've been known to like, just giving it like a synonym analogy to like, how, metals transmute to a higher element, just like chemical compounds in the body transmute to their higher, points. So this is like a mandala method does this with pure energy or pure frequency of, the EM spectrum. So
I think if you could be able to do this, you could be rich overnight by turning all your pennies into silver.
Pretty much, yeah, you could make gold. This works because the person tested this and they said that they turned a blue. They're claiming this. That's why I'm testing it myself. But a lot of the science is here in the frequency relation. Like, and I always had a feeling mandalas were not just, I don't know, something strange. Like it says right here, the Einstein's photoelectric effect theory confirmed that there is energy frequency relation in the mandala energy, even in a low tense energy, but capable of increasing or reducing the atomic molecular structure has reached the threshold of energy and the frequency of light, gamma ray, X-ray, infrared, radio waves, and microwaves. So, but with the potential energy and the imaginary total energy of the particle and the speed of light, the mandala can be reproduced carrying the same particles and energy. It uses that is similar to the construct and effects of low dose gamma radiation and other scientific researches, which is only beneficial to the health and well-being of the individual. Okay, yada yada. And it's the prototype is a non-toxic material with no hazard or chemical content whatsoever. So, okay, they're just talking about it, but here's all the information with, how they and they have sources, quite a bit of sources actually. So they really did a lot of research, and there was another site they had here that, like, this is published in the Science Publishing Group, so it's an actual legitimate thing. So I want to see how this works. So yeah, my mind is kind of just like all over the place with what I'm testing, but hopefully I can get some results with this. And they said that the smaller the mandala picture, the more like energy it's got. So that makes sense if being smaller wavelengths, smaller picture would compress the energy, emission out. So.
But this just, me, it sounds pretty weird because it's sounding like it's a very weak effect, but it's an effect that changes things quite radically. And if that's the case, why isn't that going on all the time? It's like I would come in every now and then and find my stack of pennies. There'd be one silver penny in there or something because of this effect. But that's not.
That's true. Like I said, I'm gonna test it and to see if there's any validity claim to this. Like I said, if it's just a bunch of hogwash, then well, there you go. But yeah, it's interesting. Huh?
The medical effects of this thing might be interesting because that's something that might relate to how we change over time is due to these light radiation effects, which is actually true. We do get radiated by radiation every day.
Yeah. Well, I posted the link in the chat, so if you want to go take a look at that, you can. I bought the book, so I'm translating.
I appreciate it, but it's just not something I would be interested in reading.
Oh, no, I wouldn't say now, but it's something you can have just in case if fall back on. But other than that, that's one of the projects I'm working on, and see what happens. As far as that, I've been trying to use the cell phone as a way to like I said, extend the bandwidth, past the bandwidth, like they did with Rife with his scope did, where he took the reference beam or the opposite out of phase, beam that was hitting the object, like your evidence beam, I think that's what they call it. So your signal beam hits that object, and then you get the out of phase alignment, and then you have to like rotate it just right or whatever to get it, the opposite, loss needed, it will collapse together, the wave interference, and then it will be, you'll get your resolution past your bandwidth limit. So you'll have more perfect resolution or better resolution. So, as far as like optical interferometry, if you go type in Wikipedia, it'll tell you a lot about it. Jeremy Rise was covering that basically a couple, I think it was last year. I was checking out his video on it. So that's basically like, frequency signal analysis, right? Where you're trying to, I'm kind of a novice at this, but where you have your signal losses, your mitigation and power basically. So you're trying to get that signal gain, And that's basically what, you know, determines everything. So.
Well, if everybody's pretty much gone, I think I want to go ahead and go off too. It's getting late here myself.
Yeah, I'm falling asleep.
So, you guys have a good night.
Yeah, I'm probably gonna head out, man. Later.